All right, let's see how we're doing here. You guys should be able to hear me. Looks my microphone's working. There's Pessa. How's it going, Pessa? We're chilling on a Friday, right? It's Friday afternoon. I have been working all week and super busy. I got more work to do tonight and tomorrow. Hardening some boxes, getting some stigs in compliance on a project. I just closed up a project a few minutes ago and turned that machine off, and then that part, like that chapter, that year that I worked with that organization is done. However, they can still use me in the future if they need. And then I'm moving on to doing some more security related stuff, but still it's all high performance compute. Everything I do is high performance compute, right? So I'm doing that. And I thought we'd just hang out, talk a little shop today. We got Prometheus stuff we can do. We've got like getting into Linux, and we're not going to do the Socratic stuff today so much, but we're going to do like, I'll ask some questions around like, these are the questions that I ask like Linux engineers and platform engineers. So we can talk through those. They're the ones that are like kind of my standard ones if people bring me in on technical interviews. I have a bunch of other questions that we could talk through if you guys wanted as well. So we've got the high performance compute ones and the site reliability engineering ones. So, and those are ones that I've used with an organization before to help them find people, right? Technical people. So, all right. Other than that, that's what we're working on. Let's go check on Ranger. How's Ranger doing? Look, it's like 100 and something degrees in Phoenix right now. It's right at 100 actually. It's probably because it's been very humid here and we've had a lot of. Oh, it says it's 106 here right now. So it's 106 where I'm at. So Ranger is chilling downstairs. I put his other bed back and he immediately started laying on it. We had it in the other room because we had guests over and he wanted to hang out by the guests, so we put the bed in there. But he's been laying on both of them. It's 73 down there, so don't be thinking Ranger's too hot or anything. It's nice and cool for him. All right, what was I going to tell you guys about then? So let me show you one thing before I get too far into things. We did all that Socratic Ansible stuff the other day, and you know people tend to like that. So I put all those notes here. So if you want to look through all the notes of everything we did, you can download them and you can do whatever you want. There's also the PowerPoint that goes with it. So the PowerPoint asks you a bunch of questions. There's the couple of YouTube videos on it as well if people want to do that. I guess on the Twitch side you can go look at that too if you wanted. But it's like just a bunch of questions like, can you do this? Can you do that? And then just a bunch of commands that we use to find those answers, right? So can you do this? Can you do that? And you ask yourself and then you figure out if you understand the things as well as you think, right? So there are, I mean, you'd have to download this to open them all, but there's 302 more lines. I think there's 400 something total lines in that file, almost 500 lines of just commands and things that we did as we were working through that stuff. So we're not going to spend too much time on that, but we have a bunch of events coming up, and the events are on the 3rd and the 4th of August. So if anyone wants to come and hang out with us on those days, they are free events. You just come hang out. I'm going to talk about engineering. Timotheus, my brother, is going to talk about getting into data analytics and how he got into that role and what he does in that role every day and all that kind of stuff. M-Pesa, who's around right now, is going to talk about eBPF topics and site reliability engineering type stuff that he's run into in his career. And he'll probably even tell you guys a little bit about the certs he's done and those kind of things because that's a thing that interests him. That's an activity he does when he has time. So there's that. Robbie Reed is going to come and talk about CI/CD and this long name of a thing that's basically CI/CD that he does. That's all day one. So on day one, there's going to be a bunch of stuff, all free. Come talk to different engineers, see what they're doing, all that kind of stuff. Then the second day, we're going to have Fisherman come out, and he's going to talk about bots and being at AWS and all that kind of stuff. He's been doing a lot with AI generation, and I think that's what his topic might be on, is heavily in kind of AI type stuff. So he's going to do that. And then we're going to have Ben talk about data analytics. He is a professor of econometrics, not econ, but the metrics of it. He's going to do that, and then Jared's going to talk more data. So there's a lot of data analytics and programming. And then the last one's going to be systems engineering and scale with Sending Ground. So I think I told you guys this the other day, we've got a director of engineering, we've got a professor of mathematics and econometrics, we've got a few data analytics guys coming. I'd say half the people have master's degrees and higher, and the other ones just have gone really far in their career. You know, it doesn't really matter, but I'm saying some people care about that stuff. So, anyways, you guys are welcome to come and hang out and talk and do all that stuff. You can be about as impressed as Ranger is right there, because Ranger's not impressed with nothing we do around here. That's my guard dog down there. So, all right, so what are we doing today then? We're talking a little bit about Linux, probably, I don't know, maybe build some stuff in the home lab a little bit. Maybe look at some of the things that we have available there. And then, talking about getting the role and getting into the job and that kind of stuff. So I guess that's kind of where I'm at. I don't really have like a huge schedule planned for today. We're just kind of, we're kind of like Ranger down there, just kind of chilling on the end of a Friday. Again, I've got more work to do here in a few hours, but I have a little bit of a lull, so I decided I'd hop on and do something that I wanted to do. So, all right. Well, with that, I guess let's pull up. What do I got here? Do I got anything good here? That's all the Prometheus stuff, learning Ansible. And by the way, people have asked, and one of the things that we're going to do here, but I'll probably start it. I was going to start it tonight, but I'm way too busy with work. We're going to do the Ansible version of that Socratic stuff. So again, Socratic method is where we ask ourselves a bunch of questions, and then we figure out, how do we come to those conclusions and what do we know about a thing? Well, I have one of those that's all drawn up for Ansible as well. So we'll do the Ansible Socratic method, and I have a whole bunch of stuff in there, all kinds of questions and all kinds of things that we can practice. I just don't have time to start it just yet. So I have it all prepped up and ready to go. We're just not going to do it just yet. So we'll probably, I don't know, maybe start that tomorrow. But that'll be recorded, so you can always come back and look at it later if you miss it. All right. So, all those things being said, let's do this. Let's look at I probably should draw out the home infrastructure that I've got, but let's start with, because I know what a lot of people are hanging around for is, not necessarily advice. I mean, I don't even care to give advice if we're being honest. But like, people are hanging around because they want to maybe see about getting into the field, right? Learning how to do this stuff. And I was thinking about this the other day. One of the things when you look at a lot of this like training and stuff out there, people are selling like easy. They're like this is easy. And one of the reasons I think a lot of people don't like college is college sells hard. It sells a long time. You have to do this stuff. And I was thinking about it, and I was like, I really can't sell you easy either, because a lot of this stuff you just have to keep doing it. There's no like shortcut method to learn Linux. And corollary to that, there's so many people that are just like, well, I know more than everybody anyway. So it's like, well, that's cool. Just go get the job in the field then. Like, why can't you do it? So the thing I'm going to show you a little bit here is we'll discuss things that I like to ask engineers when I'm interviewing them. And I've told you guys I've had well over 300 professional technical interviews that I've given. They always bring me in for the technical stuff. So these are the things that I ask Linux engineers or like platform engineers. And the first thing I always ask, especially if we're in a Red Hat shop, is how would you rate your Red Hat Enterprise Linux experience? What version of it have you worked with? So that would change if we were in like a SLES shop or something like that. And that would change if we were in an Ubuntu shop. I've never been in a big Ubuntu shop, but like, let's say RHEL is mostly what I've used in my career. So I would say, what's your RHEL experience and what versions have you worked with? If they tell me high, then I ask what experience do they have with updating and setting up repositories? Have they worked with satellite? What's the default logging path for RHEL? And then here's the answer. And then what files might you find in there? And I think that most people that have worked with Red Hat would probably know that you're going to find varlog messages and varlog secure in there. Those are like the two primary places that everything goes. But maybe they talk about the Apache logs or something, because that's something they've got a lot of familiarity with or something like that. Heather over on YouTube said, what were we talking about today? We're just talking about kind of getting the job, Linux general stuff, hanging out. It's not super structured today, Heather. So we're just kind of going through stuff. So I always ask people, how would they rate their own experience, and if they say, oh, I don't know how to answer that, then I say, just give me like between a 0 and a 10. Just let me know, and if they tell me 9, I go, okay, well, that's going to judge how I ask the questions from now on. And if they tell me like 7, then that's going to judge how I ask the questions, right? But then if they tell me low, I say, what other experiences have you worked with? And I do a lot of, like, I've had a lot of interns over the years, and like, and kind of, not beginner Linux engineers, but like a lot of kind of junior Linux engineers. So I'll ask them, what other Linux operating systems have you worked with? Have you done any patches or deployments? It's perfectly okay to say I've never patched anything but the machine I've worked on. It's just we got to get some experience with doing deployments and doing patches of things that are not just your local machine, right? One machine at a time is fine, but we've got thousands of machines, so we got to figure out how to get you doing, multiple. And there's a lot of techniques and stuff, and I can show a lot of that stuff even on stream here with Ansible. I show you guys how to do patching and stuff. But it's one of these things that we just have to get people experience. And then I might ask, like, if they're really a beginner, what does dmessage show? Like what happens if I type in dmessage on my machine? Maybe I type it through more. What is that going to show me in my system? It looks like it's got some kernel failures here. But what do I get out of dmessage? And this is an interesting point. Does it change if the system's been up for, in my case, 182 days? Does the ring buffer go all the way back to the start? Doesn't look like it in this case. No, it doesn't. Doesn't go all the way back. So dmessage shows what's called the kernel buffer, or some people call it the ring 0 buffer. That's more of a computer science-y concept to call it a ring 0 buffer. Whereas Linux tends to call it like a kernel buffer. And it's just all the things that have happened in the kernel since it just rebooted. I think I have I have boxes that have rebooted in the last few minutes or a little bit. Tomorrow, can I make a video on the patching process? Yeah, well, I have a stream, not a stream, a video. I guess I don't have anything directly on the patching process tomorrow. Yeah, I could put something together. Wait, hold on. Where do I got it? I finally put this on as my lab to do, and just say Linux Labs key. It's not really a Linux lab though. Hold on. It's more of just a generic thing. Don't worry, some of this stuff is me yelling at myself. Set up a patching process procedure. That's part of my overall. That is actually technically a part of my overall systems administration thing, because patching process falls under operational work, right? Non-major nerd, how's it going? We are literally just going through, where are we at? We were in like questions that I ask about, like Linux engineers or new platform engineers that are coming into an organization. And we were really just on the first one. And then I was going to tell you guys a story about this that I think is kind of funny. Most of the management involved in this have left the company, so I don't mind saying it. Yeah, actually, I don't mind saying it. Well, the one manager that didn't leave the company yet, I don't think she cares that much that I bring this up, but it's kind of funny. So when I worked at AAA, before I left there middle of last year, actually about a year ago, I left AAA, and I was their red team lead, right? So I was the red team lead for all of security, the technical lead, not a manager. The manager and the manager's manager got let go while I was there, so that was kind of weird. And I reported directly to the new CISO that was over there. He's a new CISO, but he's been there about a year and a half now. Well, anyways, before I left there, I was the platform engineering team lead for all of our platforms, right? All of our Linux and Windows, and I've told you guys it was about 5,000 machines. And when I left that team to go over to the red team, the manager there, she was great, but the director above her, I don't think he liked me very much. I had a bunch of reasons for that, and I don't really care much if he liked me or not. I just care if my work was good. But anyways, where I'm going with this is When I left, they were going to hire a bunch of people because like 2 other people left right away as I left the team. So like 2 other guys left. And what happened was they didn't want to ask me for my questions, like these questions. So they asked my brother, "Hey, could you come in and do technical interviews for us? Can you help us out with these technical interviews?" And it was funny. He came to me and goes, "Scott, can you just give me a copy of those questions?" So I thought it was really funny. Like they avoided using me, but they ended up using my questions anyways. It was just my brother that did them, and he could have made these questions up himself. It's just that he didn't want to make them up himself, so they pulled him in, and they wanted to avoid using me and asking me a favor, but they ended up using my questions anyways. So we had a good laugh at that. But anyways, so here's another one. If I gave you a raw disk, what are the steps you might take to add it to the system? So if we were just on Red Node here, right? And we said PVS, VGS, LVS, and then we did an fdisk-l, grep-i for XVD, and you see there's one disk on that box, right? There's just one disk. What would we do if we came to that device and somebody gave me another disk? So I'm just going to add a disk. I'm just going to call this stream disk, right? And we'll just make it 10 gigs. It'll be a little 10 gig disk. Boom. Add the disk in. So that disk will be added to the system. Doesn't have to boot or anything. Look, nothing up my sleeve. You just saw me add it. And I just go ahead and do an fdisk. And there's my XVDB disk. Brand new, piping hot off of the XCPNG, right? Directly to the system. We used to have to scan the host bus, if some of you remember. You used to have to do like sys, device class, everything, and then you'd put the 3 dashes into it, and it would reset the system bus, and then you'd find your devices, right? We don't have to do any of that anymore, right? Most of this stuff's all hot swappable. So I've got a new disk. Here's a question for you as we talk about this. If I gave you a raw disk, what steps might you use to add it to the LVM system? And these are the answers here, obviously. But if you don't know, what do PVS, VGS, and LVS show? So when I did these commands up here, if you're more junior engineer, what did I just see right here? If you don't know, you might need to brush up on LVM. LVM is a very common method nowadays for, it's honestly treating disks inside of a Linux system like they're a storage area network disk. That's pretty much what we're doing, pretty much. All right, so I got this disk. And let me ask you this, without doing anything in it, if I do a PVS, is it going to show up here as a physical volume in my logical volume management system? Is that going to be there? Is Leith back? I haven't seen Leith in a while. Oh, yeah, tomorrow morning. Yeah, I forgot. The same, right? So the answer is no, right? This is one of those ideas that I always tell you guys about. One test is worth 1,000 expert opinions. I could guess all day, and we could sit here and argue about it, but no, that 10 gigs is still not being used. So then I say, well, there's a command, there's a pv create command, pv create dev xvdb. And at the end of the day, if nobody else told you anything about this command and you did it on let's say you had a little test box to do this on, which by the way, I'm going to start adding these with, so we've got the dungeon nodes that you guys can jump into. You got to be in the Discord and go down the sandbox to see how to jump into the boxes. I'm going to start building them so they always have 3 disks on them. And then if you want to come in and you want to muck around with those disks and do all this kind of stuff, you're going to have that authority to do that, because that's what these boxes are for, is for people to play with. Killer Coda is awesome, but the problem with Killer Coda is I can't put you in an environment where you have control of the hardware. They're virtual machines. It's an excellent place to play around and do stuff, but if you really want to like have control of the virtual machine, you need something else. You need to go a little bit deeper. You need to build your own home lab, or you need to spin up some boxes in AWS, or you need to use our little sandbox environment for you guys, something else. But let's create this real quick. And it says, look at that, volume XVDB successfully created, and it's now part of the physical volumes of the logical volume management system of my CentOS 7 box. Sorry, this is an Ubuntu box. Okay, this is an Ubuntu box. But it's the same. It's actually, it's one of the things that's like very similar across all the different platforms. So, all right, so that's there. But are we really doing anything with it? Not really. It's just kind of sitting there. I say, okay, that's good. So we're not doing anything with it. But what are the steps that I need to do to add that to the system? So we added it into physical volume management, but maybe I wanted to add it to the overall disk. So let's clear up the screen. We'll do a df-h, and our root is mounted on dev mapper Ubuntu volume group, Ubuntu logical volume management, or logical volume of logical volume management, right? So that's got a total size of 14 gigs. It's got 9 gigs used. And if we do our PVS, VGS, and LVS, we see that it is 14 gigs, true. But it's also got another 14 gigs free here. So we could make this bigger right now without even adding this disk to the volume group. All we would do is say LV extend, so we can add to the size of this right here, our dev mapper on Ubuntu volume group, our root volume, our root drive. Maybe it's filling up because of logs, or it's filling up because people are putting some applications on it and testing. And we need to use this extra space that's just, it's out there, but we haven't allocated it anywhere yet. It's kind of just sitting under the hood, getting ready. You know, it's ready to go somewhere, but we're not doing anything with it. So we'll say LV extend -R -L plus 100% free. Let's just give it all of it. Might be a lowercase l, I always forget. And then we're going to use that full long path right there. All right, and that should, it's a dash, it's lowercase l. I always get this mixed up. I always forget, I was doing wrong too. This will extend my system live while we're running it. And if I do a df-h on root now, it is 28 gigs instead of only 14 gigs because we expanded it. But we added that disk for a reason, and that disk isn't being used still. So if I were to ask you a question right now and say, hey, is that disk being used? No, that disk is not there. It's not in the volume group. It's definitely not in the logical volumes yet. But we needed 10 more gigs. We need, let's say, 38 total gigs on this device for some reason, or on the system. We're really going to put a big tool in there, and then we're going to do some testing and stuff in our dev environment. So the original disk that came with the virtual machine that we deployed isn't big enough. So we've added another one. Again, we're playing around in a lab, so it's kind of smaller. And we want to make that 10 gigs bigger. What we have to do is we've given, so we had a physical volume, and then we had a volume group and a logical volume, and we're going to add another physical volume. We've done that, XVDB. But now the volume group has to be pulled over the top. So now two different systems, or two different physical volumes are going to exist under that logical volume. It's almost like you pull a swimmer's cap over the top of it, right? And then we're going to allocate from that, we carve from that our logical volumes, but our logical volume already exists. So we're really just going to extend that across the whole volume group. That's what we're going to do. So the way it tends to look, I don't think I have a good drawing of it. I don't think I ever bothered. I drew up some disk stuff, but I don't think I ever drew up this part of it. Hold on real quick. Let's go. See if we can open a file real quick. Come on. I think I just called it. I can never remember where this is, guys. 1 second. It's Linux group, and then I think it's our drawings. That's not under stuff. I always thought it was Excalidraw. There we go. Drawings Excalidraw. Anyways, it's in here. And I want to say it was disk. Storage. I don't know if I ever finished this up. Hold on. No, that's home stuff. I don't remember. Nothing there. Oh well. I don't know. I don't know where it is, guys. I have to look around for it. Just sworn it was down in one of these. Anyways, it doesn't matter. Look for it later. But the point is, we carve it up, right? And to then now use that, we're going to say VG extend. So VG extend. And VG extend is going to be, hey, how's it going, Paul? It's been a while, man. I don't know if you've been around trying to hide from the heat or whatever, but it's pretty brutal out here in Phoenix. Now we're going to take the name of that logic or that volume group, so Ubuntu-VG, and we're going to give it that dev xvdb disk. So now it's going to extend over it. So now when we say PVS, it's used in that volume group, and when we do VGS, we'll see that it's extended, but it's not using any of that disk yet. And then this is actually the easy thing, is we'll just go ahead and tell that logical volume to extend over the entirety of the free part of the volume group, which is that whole disk, and this will extend out our file system by that last little bit. So now if we do this, we'll see that we've got a 38 gig disk, total size of our directory. All of our physical volumes are used now. All of our volume groups are, or one volume group, all of the space is used. And then if we do our logical volumes, we'll see the full size of it. So you can do stuff like this, and this is fine. By the way, Ansible can do this for you. Ansible can carve disks for you as well, which is actually a thing that I used to use when we would add really big, sometimes within the op directory, which is where we would put application code. Sometimes they would need, in our teams, they could request 600 gig blocks of disks. And I think we would give them smaller disks if they asked, but by default, if they were like, we just need more space, I think we gave them like 600 gigs. And my Ansible would just go find those disks, and it would just do this to them. It would do that process right there. And you say, well, how hard is that to do? Well, it's this right here. It's that same thing I just did, the same exact logical steps that we did, but then it's this. You just come here, and you say Ansible module for LVM, right? And it's like the LVOL, right? General LVOL right here. I haven't even looked at this thing in fact, the last time I did this was it would have been about 3 years ago. So I haven't looked at this module in 3 years, and the reason I tell you that is to say, but look how easy this is. Create a new logical volume of 512 megs. Volume group is Firefly, so the volume group for us would be on Ubuntu --LV or VG. The logical volume is test, and there's its size, 512 megs. If you need to create a logical volume with 512 with disks dev SDA and SDVB, it'll make the logical volume from these physical volumes, and then the physical volumes will have the volume group Firefly and the logical volume test. So the two disks will get aggregated up under one volume group. Again, volume group is like a, if you want to think of it as like a rubber band holding them all together, and then your logical volumes are carved from it, kind of like you carve layers from a cake or whatever, right? Something like that. Create a logical volume, create a cache pool. There's all kinds of other things you can do. You can actually give it physical volumes. This is all logical stuff. Remove a logical volume, remove them. Make a thin pool and a thin volume. So thin pools will start very small, and then they will use more space as they need them. It's actually a concept that we use quite a bit in our virtualization space as well, right? So anyways, all this to show you that, like, once you do something, I'm a firm believer as an engineer that I just have to do something once and kind of understand, and then maybe even go like this and go, again, the question was, if I gave you a raw disk, what steps might you use to add it to logical volume management? You go, okay, PV create to give it to logical volume management, VG extend to add it to a volume group, to extend a volume group over it that already exists, or VG create to create a new volume group and just add that one disk, and then LV extend to extend a logical volume that's already there over it, or LV create for a brand new one, right? And this is like that. Then once you know how to do it, then and you can conceptualize it, right? Because again, the idea is that we can do a thing from start to finish. Then we can go automate it, and then automation, in my mind, is simply doing the steps over and over and over again. And you might say, well, Scott, what if a disk comes out and it's not the right size, or what if a disk comes out and it's got the wrong name, and this and this and this? Then we can start dealing with that. That's our FMEA, right? Our failure modes and effects analysis that we've done in other labs, where we talk about like what do we do to deal with these different problems that can come up, right? But we don't have to worry about that. It's actually funny. I have a really dark blue shirt on, but it's still green. It's kind of funny. It's like you can see stuff passing through me. Or the thing is scaling it as green half of the time, which I think is kind of funny. But anyways, yeah, what was I saying? You should be able to do all these things and step through the processes of them. And I think that somebody that tells me they're like a more senior or a principal, like they understand what's going on, will be able to do that. They'll be able to talk through those pieces. If you don't know, what you start with is, do I at least understand the individual pieces? And I think there's actually, you know what, now that I think about it, I think there's a really good write-up. Who's got a really good write-up on logical volume management? I think there's a really good one of these for Rocky Linux. I'm pretty sure there is. Let's see. Let's see if they have one. Because Rocky, by the way, their documentation in general is pretty good. Real quick, some of you are going to say, Scott, you did PVS, VGS, and LVS and got us these little things. Why didn't you do the PV display, VG display, and LV display? And the answer is, I didn't care. These look how much information you can dump. A tremendous amount of look at this real quick. Hold on. PVS versus PV display. But I don't care about all that. I just needed the name. Does that make sense? VGS or VG display. It depends how far you need to go in there, right? It depends. It depends what we're trying to do. Yeah, a Monkey Man. Yeah, that's actually part of the mystique, right? The mystique of the channel. I'm either here or I'm not, right? LVS to just show it, or LV display to dump way more crap to the screen than you might need. You might need that when you're first looking at a server if you've never been on it before. You want to see how it's set up. You might want to see if it's got any type of RAID, because there could be RAID going on here at the logical volume level. You can have a RAID allocation. You could know how many segments it's across, all kinds of things. There are things that we might want to know there. But maybe you don't care about that, and that's what that quick PVS, VGS, LVS does. But anyway, so they have a whole bunch of stuff. Look at this. You can rename them. I've never even seen that. So you can rename logical volume from data to storage inside of a volume group if you want to. I've never done that. I've never even messed with that. So I'll link this to you guys if you want. But the reason I bring this up is because, the reason I bring this up is there's a lot of there's a lot to know and a lot to mess with on this. But at the end of the day, the tasks you're going to do are all going to come based on kind of how much you understand this. So there's a link. There's a link for you guys over here. So again, you're just kind of working through. Is there another one? I think that's not their Rocky document. That's just something. Let's go on their Rocky docs, because they have that's not them either. Hold on. We want to find Rocky. They have a pretty good set of documentation. Here you go. So if you've never seen physical to partitions, they show that, which is super useful, and you have 4, but you give up the 4th one for extended, and then you can have like another 63 or something extended. So that's where you get all your disks from, right? But then they talk about, so this is actually really good, just basic primer. I've been looking at some of their stuff in general. Their SE Linux primer is really good. So if you guys want good, like, hey, I need to understand this better to be a systems admin, I really do think this Rocky, they've got some good stuff. Look, they're talking about logical volume management, and they're talking about that aggregation of your 2 disks up into a volume group. And then from your volume group, you're going to carve that down into your logical volumes. It's almost like your physical volumes are like layers of a cake, and then your volume group is the whole cake, and then your logical volumes are carved from it, which again is the exact same way that the storage area networks work. We take JBODs, just a bunch of disks, we put them up into these big RAID 6 arrays, like 8+2 and whatever different RAID arrays that we do, and then we turn them into big, we just give them a bunch of big storage pools, typically, depending on the tool you're using, GPFS or Lustre, and those are the big ones that I know and use. And then we carve them down into like LUNs, which are your logical unit numbers, and then we give those to different things. In GPFS and Lustre, we don't do that. We just make the big pools, and then you connect in as a client. But different ones of these are different ways. You can have different modes for the things, and then here's the different commands. You can also do PV scans and look at them. You can create them, and you can remove them, and you can extend them, and you can reduce them. There's all kinds of stuff you can do to these things. But that's a pretty good little primer. But again, to do this, you can't do this inside of something like Killer Coda because you don't have extra disks to work with. But in the Prolog lab, in the lab that I present for people, you can get in there. In fact, I'm on one of the boxes right here. Rednote is one of those boxes that people can get into. And we have different levels of use. Let's see. Nobody's used it in the last 24 hours because there's been no logins. I'll see one login tomorrow for this. I'll have been on Rednote once, so it'll show one login for me. Wait, unless I came in as root. It won't show me as root. But anyway, so that's that. Then I ask, what's a journaled file system? So this is something I like to ask engineers. What's a journaled file system? What's the difference with like a modern? And then can you give me an example? That kind of stuff. What does a journaled operating system do? And why does it matter to be journaled? And then in our Linux space, which ones are journaled? The ones that you're going to run into. Which ones aren't journaled and why do we care, right? That kind of stuff. So I like to ask that. I think most senior staff, principal type engineers now were around when there weren't journaled file systems, so they understand the implications. So they can typically explain that to me. I'm not saying that a more junior engineer couldn't know this. I'm just saying that it tends to be something that like the staff engineers lived through, right? They were actually on the systems back then. But what happens, right? And let's see if they have any good. Let's see. I just want to give this Rocky Linux. Do they have journaled? Let's see. I might just tell you guys to go read all their stuff. No, that's still back on just parted stuff. This is really an excellent thing, though. This is a good little primer. I think that I'd really recommend people spend some time there if they're not familiar. That's a specific tool of journaling. That's a different topic. All right. Well, anyways, journaling in a file system is where we don't change a file that's there. A file that's back that's sitting on disk, you can read from it all you want, but any writes to that file are actually written to a new location. And when that's done being written, we just flip the inode pointer over to the new location. And the reason we do that is because an older operating system, this is where you used to get the blue screen of death in Windows all the time, was they would be writing to the file and the file would be changing in real time. And during that 60 milliseconds or something that the file was changing, the system would go down. And when it came up, it would be a corrupt file. Well, in this case, you've got a file that's not changing. So if the system went down, it would just come up to the old file and then you'd have a working, booting system. But if you were making a change to the system file, you'd be making the change in the journaled location. And then when you're ready, it would be not even half a millisecond to just flip over to the new inode. And that's a much, much faster. The chances of some kind of thing happening between when you flip and when you don't are much lower. And also, the original one is still good. So even if something did happen and it still used the original file, you wouldn't have a corrupt file. There's two good files before you ever make the flip to the new location. So anyways, that's it. Some examples: ext3, ext4, xfs. You will, in your depending on where you go in your Linux career, you may start with ext3 on some really old systems that are out there, but most of the time you're going to use ext4 or XFS. Robodom, I guess that could be considered a race condition. It's not like a programming race condition. Typically, Robodom, a programming race condition is where you send two things off, and one is going to like check a value at certain times, but the other one hasn't gotten there yet. They're racing, and it goes to check a value before it's set or something. That's typically what they mean when they say a race condition, is it's two threads racing, and one goes to check something that's not there yet. So one of the solutions to those type of race conditions is just have an initial value set. Initialize your variables before you start, right? That's actually why they don't tell you guys that. Like if you ever take computer science class, they don't tell you that, but that's why you initialize a lot of variables at the beginning of stuff, just so that there's no chance of a race condition. It's not the only reason, but it's one of them. But, you know, take that for what it's worth. What experience do you have? This is huge, right? Like none of us do Linux systems in a vacuum. None of us out there, like I tell you guys all the time, like I've never worked anywhere where they're like, all right, we're just going to spin up 1,000 Linux boxes just to be able to say, like, just be able to check like a box in our company that we have 1,000 Linux servers. Nobody's ever done that in the history of this world. Nobody's spun up 1,000 boxes just to do it. They spin them up to interact with other stuff. They interact with the network, they interact with storage, they interact with users. And in this case, what experience do you have hooking RHEL or other Linux systems up to LDAP? You know, some Active Directory, because we tend to not run NIS anywhere. I've only run NIS in one place ever, and that was a really, really old project with Lockheed Martin. NIS is Network Information Services. So Linux can have a centralized location that keeps track of all your users, a NIS database. That's very, very doable. I've only ever seen it once professionally, and I doubt most Linux engineers you ever run into will have done that. That being said, how do we tie into with RHEL? How do we tie into like Active Directory in a company? And do you have any experience with it? So these are my questions that I would ask engineers, right? So before RHEL 7, we used to use a lot of Winbind and Samba to do it, and there were tools there, things that you might have to have worked with to get that working. That was a Kerberos-based authentication, Winbind and Samba, and then Kerberos was the back end. But then the newer method is like SSSD, but there's also one out there with Red Hat called IDM, right? So IDM can come in and it can sit there and it can create a trust authority, which, by the way, trust authorities are very common now in cloud, in, I don't know, I was going to say Azure, but AWS, Azure, all of these things, like you trust between the Active Directory and like the Azure Active Directory, or there's an AWS Active Directory too, right? So you can establish these trusts, and IDM's no different. It trusts the Active Directory, and then it can communicate, and then your Linux systems can communicate with that. So even if that communication's down, your Linux systems are never without a base ability to, trust users, or what we call the AAA, right? Which is authenticate, authorize, and audit our users, right? Those are the three things we always want to do. We need to authenticate. We need to prove you are who you say you are with a password or a PIN or whatever. Then we need to authorize you to the resources that you should or shouldn't have. And then we need to audit and log the things that you do and prove that you did those things, right? Those are the three things that we need to do. But again, us Linux engineers don't necessarily want to do that. I want to go build Linux servers, right? So my point in saying all that is I asked my engineers or potential engineers that want to come work for me, what have you done with that? And if you say none, I've never done any of that, then I say, well, what do you know? What's in etc pamd? Like if you've never done any of those things, that's fine. It says if they tell me about those, I might ask about etc pamd, what happens in PAM modules. Like even if they can't tell me that, I might just say, well, what goes on in PAM? What is the pluggable authentication module, and what does that mean in the system, right? What does it mean that a tool calls PAM to validate, right? Because that's what PAM is doing is it's your pluggable authentication modules. They're the only thing in the system that can go back and look at the shadow and verify that the user is who they say they are. They're the only things that can go and validate that people have the permissions to do certain things. That's what all those pluggable authentication module files do. And actually, if you go look up the PAM modules, there's not a lot on them on the internet. There's not a lot of write-ups on them. But one of our guys, M-Pesa, actually has some blog posts that are very high in the search rankings on Google. So if you look M-Pesa, and then yeah, that's how you would spell it. And like PAM modules, you'll find his blog posts in Google because there's not that many people writing about them. And he kind of went and did like a real big deep dive into them when he was acing his RHCSA and RHCE. So he wrote up a bunch of stuff about him. He's one of the guys coming and talking from the SRE space. He's come and talked to the group a couple times before too. So he used to work with me at AAA. I used to work with his dad too, which is kind of funny. And then he got married. I think it was earlier this year, late last year, earlier this year. I don't remember anymore. I think it was earlier this year. He got married, and me and the wife went over to his wedding. Well, we went to the reception. The wedding was at a temple, so we went to the thing after. So that was kind of good. Tomorrow, the talks are in. They're on the 3rd and 4th of August. So I'm giving people a long runway. There's a long runway before the talks. I want to see if we can break. I would like to see us break Discord. We've had about 28 people before in a room, but I know it can support 100 at least. But I'd like to see if we can get up like well over 100 in there. I think that would be fun. So hopefully people will get in there and come do some stuff. Okay. Tomorrow, you want to give a talk on something? Okay. Yeah. If you got something that you want to talk about tomorrow, let me know. Let me know down in the Discord, and we'll talk through it. I was asking people for a while. I kept asking for a while, and I was gonna take any of our regulars that wanted to come talk for sure. So. Yeah, and tomorrow, if you just want to come to a Saturday, one of our normal Saturday meetings and talk to people, you can do that too. You don't even have to wait. It's perfectly acceptable as well. All right, so where were we at? Okay, what automation technology? So this is a big one for me, because I mean, I don't care, if you're one of these guys that sells, the guys online that are infotainers, they're not really here to, I don't know what they're here for. They're here to be popular and talk about technology, but whatever's hot in technology. They're not necessarily here to teach or learn about stuff. Some of those guys, and as best I can tell, the one thing they do sell is you got to type as fast as you can. Well, I can promise you right now, you can type 140 words a minute and you can't beat my Ansible scripts. You can't beat my Ansible deployments across 1,000 machines. You just can't do it. So where I'm going with this is I don't care how talented you are in certain ways. I care that you can build these things and think through them. So in the automation space, I want to know, what can you do to multiply your work? Because you can only do so much out of your hands. You can only type so many thousands of things a day. You can't go faster than that. There's no way. So with that, I say, what automation technologies have you worked with? If they say Ansible, I'll ask them about their host inventory. What does it look like? What formats are supported? And I'll just get a little bit from. I don't make people code or anything in front of me. That's not something that I do. But I ask them to describe it because I think people that have dealt with this and worked with this can tell me about it. What types of things can you put into an inventory? Well, you can have hosts, you can have variables, you can have inventories inside of inventories, you can have inventories inherit other inventories, you can do dynamic inventories and static inventories, all kinds of stuff. But again, I don't make them tell me that. I just give them a prompt, what have you worked with? And you use Ansible. What's a host inventory look like? And then I'll start asking a little bit more. If they go further, I'll say, well, what types of playbooks have you written? What challenges did you face? Because I think that people that have done big deploys, even if you do all of the best things in the world, you're still going to have things that you face with challenges. You're going to be like, yeah, I did all these things right, but this one little thing still got us, and then we had to do this. Have you committed and reviewed code in Git before? That's a big part of automation. If you're going to be pushing your stuff up to a Git repository, or I don't care what the tool is that you use, but have you reviewed other people's code? Have they reviewed yours? A lot of times systems engineers, like us guys down working in the trenches, we didn't have to do that up until about I don't know. I don't think I even had used Git until, I don't know, maybe even like 2018, because nobody looked at our code. We just wrote our own, Perl scripts and shell scripts and did whatever we wanted. But now we're all part of the CI/CD pipeline, so we're deploying stuff and we're putting stuff up that's being run through Ansible Tower, and we're giving to other teams to run and all this stuff. So like you have to. It's almost like we're not just living in the server room like the little server room vampire. Anybody here ever seen the IT Crowd? And the one guy, like, they get to the second season and the dude comes out of the server room and you're like, what the hell was he doing back there? Nobody even knew. Like, it's his first time showing up on the show, but it's like it's been however many episodes by that point. It's that's kind of the way we were, but we don't really get to do that anymore. Now we're the platform engineers are more out in the open. I think we're not just stuck back in our server rooms. So let me tell you guys, I've talked about this a little bit before on stream, but I'll tell you one that got us. I had tested a bunch of our deployer for in my cluster I was working on. I had to upgrade all the packages, so kernel, all the software packages from like a Red Hat distro, and then once I did that, I locked them in at a certain level. So this was the kernel we were going to. This was the all the software packages we were going to go to, and I locked that all in, right? So that's it. Boom. Then I had to take, when you go to a new kernel, you break all your OFED. OFED is your InfiniBand drivers with Mellanox, right? So you have to go download and recompile the new OFED for your environment. But here's the thing. You could compile it all and turn it into an RPM package once, but maybe you have different versions of, in our cluster, we had every year a new drop of hardware came in. It was kind of like a big Frankenstein type cluster. Frankenstein's monster, I know. But the anyways, there's a whole joke on that. But the point is, there were different versions of it, so you couldn't do that. So what we did instead was we decided to compile them everywhere. So that's fine. So that's our OFED. Then we got to our GPFS, and when you go to a new kernel, you have to rebuild your GPFS, right? So you got to build there's a thing called the MM subsystem layer. It doesn't really matter, but you got to fix that and build that. So that was done, and then we went to a new version of Slurm, and we would do that, right? So these were the 4 things that we had to do. I had extensively tested it and done all these things, and then as we were going through and actually deploying it, we got to one of our generations of nodes, and again, each generation came in at a different year. And this one, the generation was only like from like 2023. So it was, 2022. So it was only the year before. And like 80% of those nodes were built one way and 20% of them were built another way. Something with the factory, some way we ordered them. 80% of them had this problem where when we were going to the nodes, we were killing, as we pulled out the InfiniBand drivers, it took out the Ethernet as well. So Ansible was not able to reconnect and then not send any more commands, so then it was breaking. And I've explained this a little bit before on stream, but this is a challenge that we faced. It was an unexpected thing that popped up. It affected about 80% of 300 nodes, so figure that out, right? And was that 240 or something like that? And more than 240. No, it's 240, yeah. So anyway, so the point is that it affected that many, and we had to change the way automation worked, but only on those ones. And you say, well, why didn't you catch it in testing? Well, because in testing, I apparently had just randomly picked or been given, I don't remember exactly how I got them, but the nodes I had tested from that generation were in that other pool, and I never saw it. I never saw the problem. So it just happened to be the couple of nodes that I had tested on in that pool were not experiencing the problem. So then now we had to change up our automation on the fly to lob a script over. The script did everything, rebooted the node and brought it back up, and Ansible waited. Ansible didn't have control after it lobbed this thing over until it did all its changes and comes back. So where I'm going with that is that's a challenge that I faced. That was the thing that I fixed, and the automation still kind of worked, even though it was an unexpected error that kind of popped up in real time, right? So that's the type of thing that I might expect somebody to tell me. If they tell me they've used other tools that are out there, there's a bunch of other tools for automation. There's Salt, there's Salt Stack, there's Puppet, there's Chef. But if you're going to talk about Puppet or Chef or Salt, I'm going to expect you to understand how that works. I mean, I understand the architectures. I know that they're all agent based. So you have to have an agent on all your machines, and that agent has to be active and listening for it to work. And I expect you to know that. I expect you to know all that stuff. Yeah. Terraform for cloud infrastructure? That's fine. Yeah, Mr. Muddy Pants, I could talk Terraform. I did let my Terraform lapse at the end of last year, but I mean, I could still talk Terraform. I had a Terraform associate cert up until last year. So when did I get that one? 2021? Yeah, because it goes away after 3 years. No, I got that in 2020. I don't remember when I got it. But yeah, the Terraform one, I can talk to that too. But yeah, that would be a perfect thing, and I'd talk about why do we do a Terraform in it, and why do we have only the providers that we need for a deployment, and what should we, how should we edit our TF state file? Should we ever edit that? Are there instances where we can? All that kind of stuff, right? Those are the kind of things that I'd probably ask with that. This one's big. I actually have this problem right now with one of my users on a system. Where do you check if users are having problems authenticating into a new system? You might check if Winbind is running, SSHD, whatever your authentication server is. You might check for varlog secure to see if the actual connection is working or not. Yeah, live coding, that's true. Terraform's obviously had the two major things that have happened to it in the last year. Anybody know what the two major things that have happened to Terraform in the last year are? I guess we could argue one was derived from the other. Yeah, the one was the license. They went to a business source license. So OpenTofu split from them. That's true. And then the other one that came up, and then the acquisition by IBM as well. Yep. Which I talked about this a little bit in our Discord the other day. I was part of the platform LSF thing, and we were looking at using OpenLava when OpenLava came out. New close feature have I don't really use anything. Yeah, so OpenTofu has gotten a cease and desist from HashiCorp for using stuff that was open. And you might say, well, but they already responded to it. And I say, yeah, that's fine. But OpenLava responded the same way. And go look at what IBM did to them. Now that HashiCorp is owned by IBM, I don't expect that to be like... It looks like it was being like lightly handled, but I expect it to go like into the courts now, and I expect the OpenTofu project is either going to be like a hard labor of love that people stick with, or but I can't imagine. I don't know. It's not going to be good, guys. And if you want to go read the write-up that I did, you can read that. Yeah. Oh, Heather, you said too. Yeah, the license thing in IBM. Yep, those were the things. And I watched that license thing affect Elasticsearch, because Elasticsearch did it, and then now we have OpenSearch, right, in AWS or whatever. And I watched MongoDB do it with the business source license. And then actually they did server-side license. So they added the 6th clause to the server-side license. And you can go read about that. And they got ripped out all the Red Hat stuff when that happened. It was wild. I mean, I was watching it happen in real time because I was working at the time with Satellite. And they pulled all that Satellite. It was Postgres and MongoDB, and they pulled all the Mongo out of it. So it could turn out like the first node fork and force the node project itself to adapt, which it did, which killed the fork. Yeah, live coding. I can just tell you for sure that IBM is like one of the most heavy-handed companies. It's up there with Ma Bell. If you guys want, and I mentioned this a little bit in my Discord when we were talking about it, go look at what Ma Bell. So Ma Bell was the company that owned all the phones in the U.S. until it was broken up with divestiture in, I want to say it was like 82. They did divestiture. I was only 1 year old at the time, but it was like 82. They did divestiture, and then they broke it up into the 13 regional Bell operating companies. They were called the RBOCs, right? But Ma Bell was this big, it was just this, it owned all of the telecommunications for all of the U.S., and they used to sue the effing pants off of anybody that tried to do anything with the phone system. And I was explaining, I remember this when you can call it AT&T, yeah. When I was in college, I remember, because I'm the oldest of the telecommunication, or I'm the last of the telecommunication major. I'm the youngest of the telecommunication majors to come out of DeVry. My bachelor's degree is called Network Communication Management, but I was still doing all of the telecom work that IBM or that DeVry had been teaching for years in their program. and then they were switching over like a Cisco. This was back in like the early 2000s when I graduated from that. But where I'm going with that is, I remember learning about MCI tried to put radio, like we've had radio signals since the early 1900s, right? Like I mean we've had like good wireless transmission technology since World War One, and MCI tried to put that onto the phone lines to go ahead and transmit. Yeah, MCI was around back then, and they tried to transmit over some water and then connect back to another phone system. And AT&T kept that tied up in the courts for over 30 years. Go look that up. It's wild, man. It's like, yeah. And I was even mentioning to the guys, like, well, how much further along might technology have been if we had been smart enough to start building wireless 100 years ago instead of, I mean, for all intents and purposes, wireless has been around about 30 years now, right? Okay. Cell phones have been, I guess, back into the late 70s, but that's still 60 years past when it might have been, right? Anyways, all right, it doesn't matter. I try not to get too political about any of this stuff. It's just there's other things going on than just engineers pushing technology forward, right? This one. If a user puts in a ticket, they don't have access to a file system. What can you check to help them out? This is just a thing I like to ask engineers, like to see what they do. They might do LSLD to check the access, the access control list permissions, right? The ACLs. What's the read, write, execute of the file. They might check for the user or group ownership of the files, and then minimum 5 is required to traverse through a directory. So you may have read to a directory, but you can't actually go into that directory if you don't have an execute bit. So a lot of people don't know that. If you give me, if I'm in a group and you have 644 on that permissions of that directory, and I'm in the group that has permissions to that, and I only have a 4, I can't traverse into that directory and see things. So you have to have a 655, or in that case you would probably want like a 755 typically is what, and then the user owner has 7. But anyways, that's those are the things that I like to ask. Like, if I only have 30 minutes with an engineer or something, those are the kind of things I ask them. And again, those are just kind of like prompts, and then we can go all these different directions, and they can talk about all these different things or whatever. But those are like my base kind of questions that I might ask them. Mint says it's important to be aware of who owns or can own your tools. Yeah, Mint, that's a huge part of like security posture of an organization. Huge part of it. If you ever do government contracting, you guys that ever get into government contracting or not even government contracting, you might just work for a company that does stuff with the U.S. government or other governments. And I can guarantee you right now that an open source project might look really good and it might be up and coming and it might sound really awesome to use. But if there's not somebody behind that open source project, somebody who you can sign a contract with to give you support, the government won't let you use that contract, that tool. You can't do it. If you so we had, this was an interesting one. We were doing doing OpenShift at AAA. And we were evaluating because Red Hat at the time, they had it was right before they got picked up by IBM, right around when they were getting picked up by IBM. They had bought Gluster, Gluster, and they had bought Ceph. And Ceph and Gluster were both viable backend solutions for OpenShift at the time. So when you were deploying OpenShift in your Ansible, you could point it to either a Gluster FS or a Ceph backend. And we wanted to see which one had better performance. Right? So we wanted to see like what kind of, we wanted to build a little cluster here and a little cluster here, and we had the deployer, and it was super simple to do. So we did that, and then when we were getting into like the Gluster part, and we were getting down in there was this tool that you needed for Gluster to work properly, because what would happen is OpenShift would come up, and then Gluster would be over here, but you had to create for OpenShift to work, because OpenShift is just a wrapper over the top of Kubernetes, right? I'm sure somebody will say, well, it's more than that. Okay, fine. But at the end of the day, it's doing stuff on top of Kubernetes, right? It would go to Gluster, and Gluster would have to build out the persistent volumes and the persistent volume claims, right? And there was a tool in there called Rook that would do that. I can't tell you anything else about what Rook did. Full hands off. If somebody here's like a Rook dev or something and is about to tell me everything about it, I have no idea. I just know that it was part of it. And when we went to sign with them, and we were like, all right, so we've got this and this and this, and And hey, we need a little bit of support with this Rook thing because we're having an issue with the way it kind of is doing our allocations and stuff. And they said, oh, no, we don't support Rook in that configuration. And we're like, you don't support Rook? They're like, yeah, we don't support Rook. And we're like, it's literally deployed in your Ansible deployer. It's part of this generally acceptable, generally available GA solution that we're testing. And they're like, yeah, we don't actually technically support that part of it. And we're like, yeah, we're not going to be doing that then. And we had to tell them, like, you can't, like, I was like sitting in a meeting going like, am I in Bizarro world? And the architects that were sitting with me were like, we can't, right? But that was like, I remember when we were deploying that and testing it, because AAA is a pretty big company. We had a lot of servers, a lot of Red Hat. We had like 30 engineers from Red Hat out there working with us, and they brought like a trailer out, and it was like a whole big thing for like a couple weeks while we were testing that out and doing stuff. And yeah, and they like didn't even blink an eye when they told us that, and we're like, yeah, we're not probably going to go that route then. And I think the backend storage on it right now, Seth, I don't even know anymore. I know Gluster wasn't part because that whole Rook thing. And you can go look at it. Maybe it's supported now, but when we went to go deploy it, it was not supported, even though it was deployed in their GA. And when I say GA, I mean it's past beta testing and past alpha. It's generally available. Like, they are supporting it as a company. They are selling. Their salespeople are like always telling you about stuff that's coming through the pipeline, and about to come up. And that was not, it was not supported. So anyways, that was an interesting thing when that happened. Anyway, so that's that. I can go over if you guys want, because we're always talking security. We can talk about the stuff that I asked the security engineers or the security engineering interns when I bring those guys on, because I've sat in probably about 30 or 40 of those type interviews over my career, like getting people onto security teams and stuff. So we can talk about that if you guys want a little bit. But we're just over an hour. I'm going to take a break real quick. Turn myself off here. Pull up Ranger. Where's Ranger at? Where's Ranger at? Look at Ranger down there. I got to go give him food because it's about his dinner time. So I'm going to pull up my little hourglass here. Let's pull up some more. Let's see. Let's go look at our lab servers. Do we have? Yeah. Let's get some of these up. And logs and security. Yeah, we'll at least pull these up so you guys have something to look at for a little bit. Look at that Ranger dog. Go back to our Prometheus in general here. I gotta be studying on my Prometheus stuff too as well, guys. So I'm gonna be working on some of this stuff. I have some of that stuff to do. But I'll turn this on and let's say, where's my little hourglass at? So what you guys can work on, let's say break and Ranger food. Go give Ranger dinner. What you guys can do is decide what we're doing next. Robodom, I don't know if you want to start. Actually, here I'll put together a little thing. Hold on. A poll. So we'll start a poll. This will be only on the Twitch side, unfortunately. But YouTube, you guys just do whatever Twitch wants, I guess. But let's say, what do we do next? Security interview questions, or Linux security, or Prometheus, PromQL. We could practice that stuff. We could do Prometheus talk a little bit, and I'll give you guys 10 minutes on that, and then we'll start the timer over here. And you guys can vote on the Twitch side what you want to do. Robodom, I think you could make polls if you wanted to. I think you can also make predictions too. I think you got to be in the moderator thing though. I'll be right back, guys. I'm gonna go feed Ranger. How's that discussion poll going? Let me see. Yeah, Nightbot used to take Robodom out on some nights. You guys missing the chat on the YouTube side. He's talking about Robodom used to get in trouble with Nightbot and it would kick him out of the stream. It's kind of funny. We had to make him a mod to stop the Nightbot's terror. All right, let's see how this poll's doing. It looks like people want to do Prometheus. All right, that's what the people want. But we'll give it a little bit more time, and then we'll go look at Prometheus and talk through it. And I need to study it more and work on it more as well myself, so it's good. And then I only have a little bit more time before I have to probably head back and do a little bit of work stuff. So I've got work stuff to do most of the weekend here. So I missed a couple of follows, Perry Pup and DBWRW. Hopefully this stuff's useful to you guys. I need to clean some of these dashboards up a little bit. Definitely need to clean up some of my dashboards. This is one of the reasons I need to learn PromQL a little better, is to clean up the dashboards and be able to relabel them properly. All right. A couple more minutes. You guys can also vote on the Twitch side what you guys want to do next. It looks like most of the people have said that they want to do Prometheus, so that's fine. Talk through that a little bit. And then won't be on too much longer, but we can talk through that a little bit. Things are good over there, Robodom. I just finished up a project today. I didn't get get everything I wanted to done today, but I got most of the things I needed to. Handed off a lot of stuff. There's a lot of work to do on that cluster still, but that's always true, right? You always end up you just do as much as you can. You know, that's how these clusters work. That's how all these systems work. You just keep them running. You know. We call that the KTLO operations, right? Keep the lights on, keep the systems running, keep the number of systems that we're able to touch systems every day, make sure that they're working, make sure that they're behaving the way that they need to for the users. Salty doesn't work there. No, Salty moved on. He's doing some security stuff. He actually went to a company that ThinkCaf works at, so one of our other guys. It's Faint Calf. Yeah, there you go. Have Prometheus Grafana Alert Manager set up on Raspberry, but I've only ever used as a layer between exporters and Grafana. And of that, just some basic getting started stuff for the most part. Yeah, Mint, I haven't done much more either. But then what happened, Mint, was the other day I'm kind of in between certs right now. And they had a sale for 40% off, so I decided to just pick up the Prometheus cert, and then I was studying for it. So I put together a little training for myself. And really, when I finally get it all done, I'll put it up in the Discord for anybody else that wants it. But it's like for the Prometheus Certified Associate, which should be a pretty straightforward test. It's a 60-question test. You got to get 45 right on it. You got to get 75 or higher. I have all the pieces of it. I'll show you guys what it kind of looks like. And we'll do it. But take another minute. People can... in the old military saying, smoke them if you got them, and go take a break for a second if you need it, and then we'll come back and we'll hit this a little bit longer before I have to go back on to, because eventually I have to go back and do more work in the cluster I'm working on, which is it's not a side project, but it's on top of my normal job, right? So I gotta get that going. Oh, and Ranger must be in there eating now, so we'll keep an eye on him. In the meanwhile, while we're waiting, I'll show you guys this. We do have, and somebody asked about access to this. I'll get that to you, the person that asked. I'll send that over here in a little bit. But we got a bunch of events coming up. They're free. You can go hang out at any or all of them. the more of those you go to, the better chance you have of winning a prize. I've got a little prize that I'm gonna determine here in the next few weeks, because we got about 5 more weeks until this event. If you look at that in Discord, it'll be in your time. It won't be in my time, so you'll see it in whatever your time is. So it's one of the cool things about Discord is it's all local time for you. But those are things there for you guys, and then talk about that. All right, so let's go look at the. It looks like the thing we're doing next is going to be the Prometheus talk. So we'll go through some Prometheus for a little bit. I did this about a week and a half ago, and then I have not gotten in and studied my Prometheus like I need to. So we'll go through as much as we can get through in the next, I don't know, probably 40 something minutes or so, maybe a little longer. I can go, but I need to eat, and then when my boss gets back online in a little bit on the East Coast time, he and I are going to keep working on this project that I'm on. So let's get this out of the way. Let's move this out of the way. Move this out of the way. This was our logical volume management talk. And then there's this, and then here's a little cheat sheet. Get that out of the way. So, okay, we were actually already on the talk. I was using it as part of my closed captioning. If you guys don't know, I just use PowerPoint. PowerPoint's great. It looks, yeah, the Prometheus talk 1. So we'll talk through, if anybody wants to go get this cert, I don't think it's on sale anymore, but we can go check that here. Let's go check that real quick. Is the Prometheus certified? Is it still on sale? I doubt it's still on sale right now. Let's turn this off. Yeah, it's $250, but when it was on sale, which yeah, their sale's over, it was only $175 for the cert. But here's what it is, and we're going to talk about it here in a second. But let's go look at it here. So this is my Prometheus Certified Associate Study Guide. This will be going up in the Discord, but I have a couple little last bits. I have some notes on it, actually. The notes are way over here. Where do I have those notes? Way over here. Yeah, these are the things that I need to update on here. So I need to update the metrics page, spans and traces, examples for service discovery. So I have some things to add into this still. So this isn't where I need it yet. But all right, here's the start. There's about the PCA. It's Prometheus Certified Associate. It's $250 unless you buy it on sale, through the Linux Foundation. Number of questions are 60. You got 90 minutes to do them in, so that's pretty reasonable. The format is online, so you can just take it from your laptop or whatever. But you do have to download this special browser. It's called like the PSA browser or something. Then it just locks down all your apps, shuts down everything else on your laptop. It's kind of annoying, actually. Well, Heather, this is good. So Heather said over on the YouTube side, need to learn about Prometheus. Yeah, this is take away me doing it. And let's just say that hopefully this will give you a good start in how to learn about Prometheus if you wanted to. Right? Just take away from the fact that like I haven't went and gotten the cert or anything yet, but all the study stuff is in here for this. That's not that bad, Robodom. Most written type tests are between like 72 and 80% on average. I mean, they have different numbering. They'll be like 300 to 1,000, and then you have to be over like 780, and you're like, it's about the same, But anyways, some people like to muck around with that kind of stuff. But you get a free retake with this one too. So if you mess it up, you can go back, study more, and come back and try to pass it. Well, here's what it's about. It's about observability. So everything's about 20%, but you'll notice that some things are just less, and PromQL, which is the main bulk of using their language, is just a little more. But if you look at everything, every area is about 20%. So what that means on a test that's 60 questions, that you're going to get about 12 questions from each of these. And then maybe a little less, and maybe like 16 questions from this one or something. Like, right, you can muck around with those numbers a little bit, but that's about what it means, right? So you need to understand metrics, logging and log events, and tracing and spans, and pull versus push, and all these different things that we're going to talk about in here. And then I'm going to show you how to go practice them. Because for me, like just reading about the stuff, I'm going to forget it. Hearing somebody talk about it, I'll still forget it. But once I get my hands on it, there's a good chance that I'm going to be able to figure it out and get it working. So, yeah, you need to know the system architecture, how we do configurations and scraping, and understand kind of the YAML file that everything runs out of. You need to understand some of the Prometheus limitations. It is much better to pull things with Prometheus than to use the push gateway, but you can use the push gateway if you have special metrics that need to work a certain way, right? Those kind of things. Data models and labels. So once we start to add labels to our data, like we say that all these servers are infra and all these servers are dungeon, which are actually how they are in my home lab, then I can start to look across dimensions. I can say all my infrastructure servers aggregated are using an average of like 10% of their CPU, but my dungeon servers are even lower because nobody's using them, right? That kind of stuff. So there's dimensionality to things once you start adding labels, because now you're saying like group by. It's this concept of kind of like grouping by things, right? And then what the exposition format looks like. There's all these things that we're going to talk about. So this is just the body of knowledge, right? The BOK. The BOK is the body of knowledge for a thing, right? And you'll find that any test. And I often talk about this stuff where people are like, well, guys that have certs don't really know anything. And I'm like, well, that's not true. They probably know some things. Having a cert doesn't mean you're any good at being an engineer. It just means that you spent the time to learn the body of knowledge and could pass it at a 75% rate, right? It means that you went and you studied all of these things. And for some people, they want the more well-rounded engineer who's done that. And some people want somebody with at least 2 years experience. And the reason they cut off at 2 years is because that's somebody who's probably done most of these things within their 2 years, right? That's why people ask for stuff like that, right? It's not because they're just like, well, unless that person's been on the keyboard for 2 years, they don't know anything. That's not true. People probably know things. They just haven't, maybe they're just not ready to operate the tooling that they need at the level they need, right? Sometimes, like, we can't always ascribe malice to the way people do things, right? It's like a driver's test versus a good driver. It's a baseline. Yeah, it's a baseline. That's a great way to put it, Mint. There's probably no area of this where they can't at least have a little bit of knowledge. And one of the things that I always say as an engineer is I don't know everything, but I know how to reference almost everything, right? Like I know how to go reference. Like if you told me, hey, Scott, can you go do this? Can you go like ls this thing about a directory? I'd be like, I never even heard of that, but I know how to go reference it, right? I know the questions I would ask to find that out about the system. So, and that's not, and again, some things you got to know in your head and some things you got to be able to reference. But the point is, there's probably nothing at least on here that the person won't be at least familiar with. Yeah, Robdon, the Sec Plus is going to be great. And I think that's a really good baseline for you, too, for any job you're looking for in the future, I know. Robdon, are you still looking? If you don't mind me asking in front of everybody, you can message me offline if you want. You don't have to tell me on here. But if you're still looking, I'm always trying to put stuff down in our Discord, like things that I know about. But, yeah, that's good. Okay, so here's the thing that I'm a big fan of. Like I tell you guys, you'll hear it from me, you'll forget it. You'll go watch a video on it on YouTube from somebody else and you'll forget it. Maybe you'll go read about it for a little bit and then you'll fall asleep while you're reading or whatever. But one of the things that I really just don't think you forget is getting your hands on in the environment. So this is, there's 2 places on Killer Coda that you can go build for free all the stuff that you need for this. One is the server build version. So this is a Killer Coda lab that I put together called, me and the Professional Linux Users Group put together on monitoring Linux telemetry. But this one focuses on Node Exporter, Prometheus, and Grafana. And you could stand this up, and then once you had this stood up, you would have an environment very much like this right here. You would have something very much like this, but it would only have a couple nodes in it. And then you could come in here and you can go do queries. You come up here. Let's go to graph. And you could put expression queries in here, and you could practice the PromQL, the Prometheus query language, right in here. There's a link that I'm going to pull up later. It's at the end of the presentation, and it's to this cheat sheet. But I'll link it to you guys right here, but it's also in the presentation. But here you go. So here's a cheat sheet, and you can save that off. That's also down in the Discord. Excuse me. But let's say you go and stand this environment up. So you believe me that you need to get your hands on this a little bit. And you stand it up either in these free, this is the free Killer Coda environment, but you only get it for 1 hour. So you would have to spend the first minute to 5 minutes standing this up every time. So you'd lose a little bit of time every hour. Or if you have a home lab environment, you can do, there's this really good home lab build quick setup that this guy Stefan Prodan did in GitHub, where you can just download, and it's basically just a Docker stand-up of a whole Prometheus environment. I've never used this, but some of the guys in the server swore by this, and I was like, that looks pretty good. So, and it looks like a pretty good little deploy as well. So once you have these up, then you go and you hop in, like I was just showing here. You pull up your Prometheus, and you pull up this, and you just start looking up these different things. And node CPU seconds total. And here's the node CPU seconds total across my entire cluster. And then maybe, so here's all my infra as my team. And then down here a little bit, I got my team dungeon. So now then I start to maybe look for a range. So they show me how to do it by range. So I only want the last 5 minutes, right? And then I know that I can do the last 5 minutes here. And now that's a new way to query. So now it's aggregated by the last 5 minutes, and it's everything in a 5-minute range of samples within a given metric name, right? So for this where's my system going so slow? My system has decided to go. Oh man, I hope I'm not crashing right now, guys. Give me a second. Did I drop to like no frames? Because like this thing really looks like it's dying here. What's going on here? Give it a second here, guys. Are we all caught up, computer? Are we deciding to play nice again? That's what I get for using Windows. Anyways, so there we go, right? Now we've looked by 5 minutes, but what if I wanted to then like look at the rate? So instead I take all of this and I wrap it in this module, or it's called a rate. This is called a function, right? And I execute this, and now I get the rate of that across all of them. And I'm starting to, it's coming back. Thanks, Dream Traveling, for that. It looks like it's, it still seems like it's a little slow, but it's kind of funny watching this thing try to churn through over here. And I don't know, maybe I look like the old, if you guys remember the old Lawnmower Man movie from like, I think it was like late 80s, early 90s, and they had like this tech guy, but he was like, I think they called him the Mouth or something. Yeah, it's weird. It's like my system wanted to catch up for a second or something, so maybe I got to go kill some background process. Maybe I have one too many tabs open in Notepad. Well, anyway, so over here, look. The point is you could start to find things out about your system, and you could start to ask questions and pull data down and understand how these things are kind of working in your environment. But this is one of these things, like I really think that this is rubber meets the road stuff. Look at this. I want the node CPU seconds on only the first CPU, and I only want them, in my case, I want if they're not idle. So I want mode is not idle, right? Because I want, idle is not what I care about in this case. I want the not idle. So I'm going to execute that, and it'll give me them when it's IOA, IRQ, nice, soft, IQ, steel, system, but it doesn't give me idle. So I said not idle. But if I said equals idle, it would only give me the idle. So now I could see for only node CPU how idle it is. Then look, you can keep adding dimensionality here. I can say only if the team is equal to dungeon. And see how it's trying to help me out there? So now across dimensionality, it no longer gives me my home labs. It's only showing me the instances that are up in the dungeon systems, because we track them by the label dungeon, as opposed to our infra nodes, right? And that stuff all gets deployed when I deploy my node exporter, and then my Prometheus, when it scrapes those different nodes, it knows how to label the data, right? All the jobs are nodes, all the modes are, in this case, idle, and then the team could be dungeon or infra. But you might quickly say, well, how many dimensions can I have? Well, how many labels do you want to put on your data? The labels are super easy. Look at this. Look how easy it is to put labels on data. So we SSH to Prometheus in my home lab. And this is one of the reasons, back here real quick, One of the reasons it's so good to have the server build one is this Docker build and this one are your standing up Docker environments. And in those Docker environments, you're not going to have a real process running on your server with Prometheus up. Does that kind of make sense? You're running a Docker container and it'll have it in there and it'll be all configured. Well, in here, we can actually go and muck around with our config file in our server build version, but you're not going to be able to do that in these ones. You're going to have to probably send some variables in as you call and as you stand up and do your Docker run, you know, or maybe you have to go build like a Docker file and add variables in as you run it. So that to me is not going to help you with this part, the fundamentals, the architecture part, but it'll help you with all the other stuff. So it's one of these things where you just have to know like what your tooling is going to be able to do. So we come here. Where was I at? I was showing you guys this. So in our Prometheus server, etc Prometheus, and I just put them all in here because I'm lazy, but here's one of my dungeon nodes right here. And its job is node, its team is dungeon, and then its target is right here. And I didn't make this by hand. I actually made this via an Ansible playbook. The Ansible playbook stamped all these on my nodes. It stamped all this for me. Actually, I think I might have stuff down in nodes as well. No, I didn't put anything down there. I could have, though. But all the stuff that I'm tracking via Prometheus is right here. And I've shown you guys that deploy. If you need that deployer, if you're like, Scott, I kind of want to deploy something like that in my home lab, but I need your help or whatever. I had put it in here before. I think it's all the way down here. Jump to present. I think I put it in here from the other day. So hold on. Do I have it? This is examples other people have done, talking about different stuff. Sudoers, that's a Sudoers fix thing I was doing. That's Olama. Somebody did Diet Pie. That's cool. Node exporter. Yeah, this is my deployment right here for Node exporter. So if you need that, it's in our Discord, right? But this is how I built that right at the end, right there. I write at the end of my deployment, however many nodes I deployed Prometheus Node exporter to. Then when we come down here, we loop over, and for every one of those nodes that's still in the playbook, meaning it got Node exporter deployed, we write, but we only go to the primary node, which just happens to be the node in my environment. At work, I variabilized this so that you could put in any Prometheus node, and then it just writes out to this file on that node each time for each host. So target is host vars hosts, and then their IP address, and then their first address for 9100, and then that generates this file right here for each of those nodes. That's what it does right there. That's it. And when you use the copy module, you don't always have to have a source. You can generate content on the fly. And you might say, Scott, but you're a big advocate of Jinja templates. You sometimes talk about Jinja templates and stuff. Yeah, but sometimes we need something to be even faster than a Jinja template. No, this is another way to do it, guys. You can say, generate the file on the fly with me, and I'll just drop the variables in as I go. And that's what we did. That's literally what we did here. We dropped the variables in right here. So each time we looped over a node, for each node in the playbook, we did this, but we wrote the file to the Prometheus server each time. So we delegated a task, and it kind of got to the end, and then it had each server line up, and it wrote its information into one of those files. So that's how I do it. And I did that, again, I did that earlier. Actually, I think I did it in September of last year on that cluster. And it went against about 1,200 and something nodes, and it just wrote them all in. And then I didn't do it in etc Prometheus. That was a little messy. I did it down one directory called, I think I just called it nodes, like I did in my home lab. But then you just do nodes there, and it'll go right it in there. Then the scrape config file just looks like this. Cat, am I in the directory? Go up one. Cat prometheus.yaml. And then the scrape config is just scrape everything out of here that has JSON to it at the end of the name. Just grab it all. It's going to be in JSON format anyways. If you didn't notice, that's what that is. right? That's a simple JSON or JSON, whatever you want to call it. But that's part of the infrastructure stuff. And that's all part of getting your hands on this so that then you can come in here and practice your PromQL queries. So selecting series of data, looking for not CPU 0 and only when the mode is user or system. Oh, hold on a second, guys. The wife's calling me. 1 second. All right, sound check. Can you guys hear me? I think you can. Okay, the wife's on a scrapbook retreat, and she was calling me to let me know that she was good. Normally, Friday is date night, but she does scrapbooking, so she goes and hangs out with her other girlfriends and does scrapbooking. So that's fun. And then she's going to see, I think tonight they're going to see Hamilton or something. There's like a local version of Hamilton going. Yeah, I don't have to pull her. Yeah. I didn't say hold her. CC's trying to clean up my talk. Okay. So we're back. And then you can go look all kinds of things, right? And this is the thing. I need to go spend more time with this, but grabbing the rate, grabbing the I rate, and grabbing the increase, the absolute increase of something over the last hour. And in this case, we would need to have a demo API request. So if we don't have a demo API request, we would have to do something ourselves. But actually, I need to check. They have an open Prometheus here. So I wonder, yeah, it looks like they have their own Prometheus instance here. So it looks like you can actually come in here and do these queries, maybe without even getting, you know what I'm going to do? Hold on. I'm going to post this. This is in Prom Lens. Look at that. So Prom Lens apparently has its own lab that'll let you practice. So that's actually really good. Let's see. This has the API requests here. So that's really cool. I like that. So you don't even have to leave this tool to do that. So that's promlabs.com. And then the cheat sheet. Did I link that to you guys? Yeah, there you go. Boom. So now for the PromQL part, you don't even have to go do that stuff. That makes it even easier. Look at that. But again, this is one of these things you want to be well-rounded going into a test like this. So you could have, look, here's all your you could do all your PromQL stuff right in there. Now you've got a full-on playground. Yeah, that's actually really good. I want to add that here. I'm gonna put. Give me a second here, guys. It's gonna stop my text to speech for a second, but give me a second here real quick. Let's add that. Let's add that in there. And just say Home Labs, and then right here we'll say PromQL. Get rid of that, and then we'll go here and we'll say cheat sheet with a playground. So that's a cheat sheet with your playground attached. That's. I mean, I'm a big fan of like just finding free stuff on the internet in general, and that's probably one of those that's really good. Hey, Hack the Planet, how's it going? But yeah, that cheat sheet with the playground attached, that's clutch, because you could just go in there and start practicing, right? There's one other thing that I don't talk about until the end, but now it's funny, I've brought almost everything else forward. In the Prom Labs, we get all the way down here, all the way at the end of all this. Again, I'm going to put this up in the Discord eventually. Right here at the end, they have a training with Prom Labs. So let me click on this real quick and see if we can get this to pull up. And their training right here, they've got a free training. There's one you can buy, but there's a free one right here. And this is their free version. I thought this was the one I had in here. But it gives you a free introduction, which will tell you a lot about the system. So there's a lot of information in here. Tells you what Prometheus is not, which is part of what they want you to know. in the overall thing, right? It's not logging or tracing. It's not machine learning or AI natively. It is not horizontally scalable clustered storage. That's not what they're trying to do with it. Is it? Well, it's other things, but it's a time series database. It's a TSTB, right? That's what it does. So they got a lot of information here about that as well. All right. So anyways, we got that. Come back up here. This is where we were. And okay, so there's that. You'll notice some of the things I've drawn on the slides, but here's the observability concepts. We need to know our metrics. We're gathering metrics are just measurements about things, right? Measurements about things are metrics. When we talk about telemetry, we're talking about metrics at a distance. That's all this is. Understanding logs and events and how that works, even though we don't really use Prometheus for logs and events. This logging, though, is going to be something that we're going to turn on in our own Prometheus. So Prometheus does not do logging in and of itself. You want to use a tool like Loki or Graylog or something for that, right? But internally, you can turn on logging so that within your Prometheus, you can track API calls against it. And we did that, the last time I presented that, we did that in my Prometheus instance. So if we're here, we can go see right here. Where's that? Oh yeah, here's the query log file. Query log file goes out to here. And so if I went and did like a tail-f on that, right? And then I moved it over here. I'll just hit some enter keys real quick so that you see that there's a space. And then I come back over here to my Prometheus instance and I hit the front-end API with this query again. It'll show the query request. That's my machine trying to hit it. Long thing at Red Hat, been a long week. Nice Hack the Planet, nice. Did you get to stream any of the event over at Red Hat, or was it just like a work thing? I just closed out a project today, so I'm kind of relaxing a little bit, and then I've got more work to do tonight with one of my bosses. So here's the query that we did right here. Node CPU seconds, CPU mode idle team dungeon. So look, it was passed in from here. It was passed in, and then there's the exact timestamp of when it started and when the total eval time was and when the total exact time was, and we should have the finish. So we had the start here, and we should have the end. Where's the end? Well, they give us the eval time, so we can calculate the end, I guess, if we wanted to. Normally, though, you see the end time as a timestamp when it came back, so I guess that's it, too. But work thing, unfortunately, can't stream any of the cool things I do for work. Classified compute. Yeah, I get that. I sign non-disclosure agreements all over the place for the most part, which is fine. I wouldn't talk about work stuff anyways, but I can like generically talk about it. I just say I work for different colleges around the country, and I can tell you guys that I work for NOAA Weather, but that's NOAA, not NOAA Weather, which that's also a very funny mistake by my closed captioning for other reasons, but all right. So that's what a request looks like. And every time we did it for any of our different queries, it would show up there. If I did this one, boom, we would see that. And we would be able to evaluate all of those logs. And then I believe I actually took these logs. We have to go look. But in opt promtail, I'm pretty sure we sent our promtail config. Yep, we sent that query out. And then now when I do my queries, they also come here to logs. And if I go to auth log messages, syslog, what's that other one? Called it Prometheus. And then take away failed. Here's the actual requests that have been going on today for my system. And there's the actual query that I just did right there with my client IP 192.168.11.65 and the actual query and all this stuff. All the data that came back is coming out to my Loki, and then I can graph that. This is actually graphed through Grafana, so I can see that I've been messing around in my own Prometheus. Could I see if there was over amount of usage by certain users or certain processes or apps? Sure, right? But this is the kind of thing where until you measure it, how do you know? How do you know what's going on with your system? TLDR trying to work out a predecessor for VMware post Broadcom. Yeah, Broadcom. I've only seen. I haven't heard. I've only heard. I haven't seen. Let's put it that way. I haven't been working on any ESXi lately, but my understanding from people is it's been coming back between like 4 and like 12 times as much money for licensing as it used to be. And I'm just like, that's going to make companies move. That's going to make, I mean, because there were a lot of companies that were using VMware because it's kind of like the standard and it's stable. But if you're going to be like, if you're going to be that expensive, like if I was a company doing it for, yeah, if I was hearing about 4 to 12-ish, somewhere in there. Yeah. Yeah. It's, ooh, I don't know why it said 12 o'clock-ish, but anyways. 12, I don't know, whatever. But yeah, I've heard some big numbers. I haven't seen any contracts or anything. I've just been hearing it from like people in the industry and stuff that it's not cheap. So, which is funny because we actually recommend, one of the things we recommend is there's an API Academy that's free out there for people to go take their little certs on APIs, and that's by Broadcom. So I think that's kind of funny. If you ever go to apiacademy.co, I tell you guys, hey, go get this. There's free certs, there's free training. But then when you go to the very bottom, it's by Broadcom. but I mean, it's an awesome little training that's like 15 to 18 hours for people that have nothing on their resume. It's got some really good information in there about API designer, API security architect, API product manager, understanding how APIs work. If you got nothing on your resume, put that on there. But, at least Broadcom's not charging for this. All right, anyways, all right, I'll stop. But that's funny to me. Where were we at? So this is all this stuff. Pushing versus polling, service discovery, and basics of service level. These are objectives, service level agreements, and service level indicators. And the order of that tends to be service level indicators are the smallest piece. They feed up into service level objectives that you want to hit, and service level agreements are agreements you make within your company or other people that you support, or even to outside. Those are actual contractual requirements that you have to hit. So there's that. Okay. Metrics. There are different metric types out there. I need to add to this, but counter, gauges, histograms, and summaries. And you'll run into some of those if you come over here and you practice your PromQL stuff. So if you come down in here, here's series, aggregating over multiple series, math between series, and that kind of stuff, set operations, and then quantiles for histograms. So if you want to see like percentages and stuff, you can come in here and you can actually look in the graphs, and it'll show you a little bit of, oh, I like this, and then is there an explain? This will explain to you what the quantiles are. Oh, that's wonderful. That's probably one of the coolest little things I've seen for practicing. So I'm going to be doing some PromQL this weekend around some of the other work I've been doing. But that's really cool. It shows you, and whenever people talk about quantile, they're talking about where you are along a 0 to 100, right, as a percentage. So you can see that if you want. I think they probably link you over. If I had to guess, this is going to link me over. Oh, it's their stuff. Yeah, so this actually links you back to their official documentation, which is what you want to be reading anyways if you're getting ready for the search. So that's excellent. I think that's really, really good. So that's where I'd go learn about that. Monotonic functions are always increasing or always decreasing sets of data. So like a monotonic function might be overall calls to an API. Overall calls to an API will never go down. So today I had 1 call. Tomorrow I have 2. The next day I have 3. At the end of that I have 6. The aggregate number of 6 is monotonic. It's always increasing. Similarly, if I had a cake and you were all coming and taking slices of the cake, that cake would be decreasing over time. It would never increase. So that's all they mean by monotonic, is it's always increasing or always decreasing. The line always looks like this. It can be kind of jagged, but it's always going up. I mean, and when I say jagged, I mean it's always increasing, but the rate of the increase can be different, but it's always an increasing or a decreasing function. And then jobs and instances. Instances, any endpoint you can scrape, that's called an instance. And then jobs are collections of instances. Jobs are, by the way, one of the things that you put in there as a tag, right? So when we were looking at this, you had the jobs right here. Where's that? Should have had jobs right here. Yeah, job is the node. But I could set different jobs, which are collections of instances that I have. Let's see. Proxmox is an enterprise contender, but Citrix, Nutanix, Red Hat, OpenShift, and a few others. Okay. If I was future-proofing for an organization, I'd steer towards OpenShift and Kubernetes and Hypervisor in one. It's not as mature of a product as I prefer it to be. Yeah, I hacked the plan. I don't know if you were here earlier, but I was talking about when we first rolled out OpenShift at AAA years ago. So it'd been like 2019, right around the time IBM picked them up, and they came out, and we were using their deployer, and we were testing Gluster that they had just picked up and Ceph as our backends. I don't know. You weren't here for this, were you, Hack? I'll explain it again real quick just so you guys can hear. And we were testing them both, and we got the Gluster one working, but we had a little bit of problems with how Rook was carving the Gluster persistent volumes and persistent volume claims for OpenShift. And we asked them about it, and then we said, how is the host an instance of Node Exporter? That Mint, it can be. You can also have other things besides just Node Exporter. In my case, yes. An instance and Node Exporter are the same thing in my home lab, yes. I don't have anything else with the cool tooling. I need to go play with some of that a little bit, but I don't have any of that. So Hack the Planet, back to this real quick. We were doing it, and we were asking them about it, and the Gluster part, they were like, yeah, well, this was GA, by the way. This was generally available, right? They did not have, they said, well, we don't support that Rook piece. And we're like, what do you mean by that? And they're like, that's not supported by the enterprise. And we're like, but it's needed for Gluster to work. And anyway, so there's that. I talked about the Citrix Zen server, and they dropped dev availability. This install process assumes things that aren't there if you presume no domain controllers during set. Yeah. Me and my brother, so when I was there again recently before I was the red team lead, I was the platform, and me and my brother, we had put Tower in, and we had done all the configuration for the original Tower. Originally, we had been running on AWX, and even before that, I was just using Ansible as controllers on a few platforms, and I would just hit all my boxes with them, right? But when we went to kind of productionalize it, we went to AWX, right? We got this really awesome thing, and it was doing all this stuff, and then we finally paid for Tower, and we brought Tower in, and my brother and I were able to build Tower on it was a 3-node cluster. It was 3-node cluster. It was 1, 2, 3 of our execution environment nodes, and then we had a fourth node, but it didn't count as part of the cluster, and it was Postgres. So everything was sending to Postgres and all that, right? But then when he and I went to, this was right before I left, we went to deploy AAP, which is Ansible Automation Platform, which is the thing that came after Tower. He and I could not get it to work with their deployer, so we were like, "Yeah, you guys are gonna have to send us out enterprise support." He and I had done that. We had done all the updates and all the upgrades and done all that and set up, because every time because you can have different environments, like different virtual environments inside a Tower that run, and for something about the AAP part of it. By the way, we had to add a 4th server for Ansible Automation Platform. You have to have a separate Galaxy server. Well, I mean, we needed it separate because the 3 execution environment servers always had to be ready to execute across our environment of, in that environment, it's about 5,000 total nodes. So anyway, so that was something that me and my brother, we were looking at it and we were trying to get it working. We're like, we're going to F this whole thing up. You guys need to send out enterprise services. And typically he and I don't give up on stuff like that easily, but like we just kind of finally backed away and we were like, look, there's too many moving parts here. There's too much stuff going on. And we ended up letting them do that. And I left the team, so I don't know what ended up happening with that, but my brother ended up getting that working for him. But all right, so anyways, there's our metrics. Logging in events, you can turn on query log to write all queries to a server in a file. We did that, and then we sent it over back to Loki, and then Loki fed it up to Grafana. You go to your Etsy Prometheus, prometheus.yaml or YML, whatever you want, and then just add the line query log file and send it to some log file. When you do that, you have to probably make the Prometheus directory because it's not going to be there. You can verify it's turned on by metrics exposed when it's active. So you have metrics inside of Prometheus that are also going to be turned on. The log format's in JSON. We just saw that when we were looking at it. And you can rotate it with the normal Linux log rotate facilities. So you can just go here, cd to Etsy, log rotate. I didn't set this up the other day, but just go find one like, I don't know, dpkg is probably fine. And then that looks fine. And then I would just modify it to be this other log file that I'm actually reading from, which is right here, right? I'll just copy that over and call it like Prometheus log or Prometheus, and I would just rotate it in whatever way I want. This rotates monthly. It rotates every month, and it keeps 12, and then it compresses and whatever, right? You do whatever you want with those. And then you can create it at whatever things you want. Then if we go look at like var log, and then in here, we should see like the old dpackage logs down in here for this system, right? All right, anyway, so there's that. Tracing, and I need to go get this. I just drew this out the other day when we were talking. But trace is the entirety of the thing, and then span is each individual piece, I think. I need to go look this up. But trace represents the whole journey of a request or action as it moves through all the nodes. And spans are an operation or work taking place on a service. So web server responding to an individual request. So actually, I think I need to flip those, but I'll get that on there. I took a break. You're back. Nice. Yeah, Freedom Dow, I appreciate you coming by. Run a mucker, port 9090. Anyone else? I guess 8080, but not 809090. I'm not sure. What? Missed the context. Oh, yeah. Hack the planet. Yeah, if you mess up on your thing, it's done forever. All right, so, yeah, there's this. Traces and spans. Again, this is in my notes as things I need to update. So I told you guys this isn't a completely finished product here. I need to work on this a little bit. Push versus pull. Push is an endpoint pushing data into Prometheus instance. It's not the preferred method. If you push data, there's a Prometheus push gateway that'll work. But also you need to know that it's not an aggregator or a distributed counter. It's a metrics cache. So if you push things into Prometheus, they will always be there. Is 9090 standard for cockpit? Oh yeah, well then that'll be a problem because I'm pretty sure that's what Prometheus uses now too. Let me see. Is that right? Yeah, Prometheus is 9090 as well, so there you go. Pull refers to the endpoint presenting HTTP information and then having the Prometheus instance scrape the data into its database. That's a technical kind of definition that they have. And it's from a scrape. So you set up a scrape to go pull that information. Advantages of a pull, they natively can tell you if instances are down or not, because when they go to do the pull, if they don't get data, they have a timeout, and then they say that the instances are down. You're manually going to the target, inspecting the health with a web call, right? Like a command there. Extra instances are easy. So instances are easy to remove because if you push metrics, they're never removed without a manual purge. You have to go into the database and purge them. But when you pull them, if they're not there anymore and you remove them from the scrape, then they eventually fall out of the database over time, and they're not always going to be tracked when you pull metrics. They're just going to go away because they're not scraping for it anymore. So that's an important thing to know. When it's like if you push, it's always going to know about it forever. But when you pull it, it forgets it if you're not scraping for it anymore. And that's a useful thing. And that is a technical thing they say. They say in all instances where you can pull, only push if you have to. And do not treat it like a metrics cache because that's not what it's doing. That's not what it's there for. It's an aggregator or a distributed counter. It's not designed to just be a cache for your metrics where you write them in and then read them back out. That's not. It's a time series database, so it can do that, but metrics caching should be done in like etcd or Redis or something. Those are key value optimized data stores. That's what those things do faster than anybody else. Memcached I think is one, or memcached. Yeah, memcached. Yeah, that's spelled right. All right. Those are the tools you use for that. Service discovery can be file-based or HTTP-based. Using Node Exporter, you'll expose some metrics. It's always 9100 and then /metrics. You can change the port if it's needed, though. And then there's like hundreds, maybe even 1,000 registered ports that are out there that you can use. And it's very useful because you can then have this up. There's this value of up within metrics. Hey, thanks for the subscription there. Bacchiotomy. Hopefully this stuff's useful to you. Make sure you refresh your browser because you don't want to be stuck with ads. That's the main thing about subscribing over on the Twitch side. You don't have ads anymore. So, but then it's if it's HTTP based, for it to be considered up, you must get a response code of 200. So you can write. By the way, you can write your own exposed metrics. You can expose metrics yourself through a web page if you want, but the response code can't be like a 300 or something. It won't be counted as up. Content type must be application JSON, and the body must be valid JSON, or Prometheus will just error on the read, on the scrape. It won't work. So that's very kind of important to understand on the system side of things for this. All right. File discovery and HTTPD. Is it event-based? Yes, with file. It's going to have iNotify, so it's going to be watching. iNotify is a tool inside of a system that can just read if a file's changed. HTTPD is not going to be event-based, meaning it's going to scrape at an interval, typically every 10 seconds. It's going to follow whatever that refresh interval, which I think is default 10 seconds, but you can change that to slower if you want or faster, and that's going to affect what we call the resolution of our metrics. Resolution just means if I'm looking at it every 10 seconds, but then I say, well, I want to see it every 5 seconds, do I have the data, are the data available to me? If they're not, then I need to change the refresh interval, right? Is that related to ePull and stuff like that? Mint, I guess it would probably be like a common... so iNotify is its own tool inside of an operating system. And... yeah, iNotify is just... You can have iNotify running as a service, and it can just alert you if there's changes to a file. You could actually write, it's kind of like our own little poor man's, what we would call like a poor man's tripwire file. If you didn't want to stand up a tripwire, but you just wanted to watch one or two things, you could set up a service to send you messages or send Slack messages only when a file changes in some way. So there's a whole bunch of things here. Waiting for a file and yeah, so a file, you could, this is going to be, man, I'd be a little worried about that kind of crap, but they may have some iNotify in some of this. Let's see. Yeah, they're doing an iNotify like this. So anyway, so there's a whole bunch of things that have come out of iNotify. Yeah. You have them all natively probably for the last 10 years or so, but they're part of the shell for most modern operating systems. So yeah, there's a lot of stuff you can go play with those for sure. Format YAML or JSON, you must have it JSON for web transport. With the file, it's always local, but with HTTPD, you can do, so this is like HTTP, or you can do HTTPS, which means that it can be secure. You can expose this. I would always advise having, if you have end-to-end points and you control the line, you don't need to have some type of VPN, some type of, even if it's a point-to-point tunneling at like the Mac. There's actually Mac encryption now, right? Mac layer, so it's a data link layer. But if you don't want to do that, if you just want to use your HTTPS, which is what most all of us do, you can use TLS. You can have basic authentication, which I don't advise. You can do authorization header, so it can be actually sent in the header call, or you could use OAuth too as well. TLS is probably the most common. What TLS means is that you have a certificate on one side, and I keep a private version of the server certificate and never show it to anybody ever. And on the other side, there's a public one, and the public one can be shared to anybody. And if I want to send information from my private one, in fact, let's think about this. Yeah, the public one would be on all your node exporters, let's say. And when they want to communicate and verify that the scraper is coming in, it's going to encrypt something. There's a whole process to communication of TLS There's a TLS 1.2 and then a 1.3. 1.3 tends to look like this. We say hello and we send an encrypted piece of information that could only be encrypted by the private key that we have. Send it over to the public one. They would decrypt it and send it back, and then that would verify to them that we are who we say we are, right? Only could they decrypt it. Now, if you say, well, Scott, hold on, I need to know more about this because I always avoid TLS. I bring this up for you guys often because I really think it's valuable. You don't have to be the person that like ignores, like when people start talking about certificates. You might say, that's for the senior guys and the admins and the architects and stuff. No, there's no reason you can't learn it. So SPIFF. I always show you guys this. One of the people in our community helped write this book. You can go look in there. It's a free book. It's free online. It's called Solving the Bottom Turtle. And it is not directly in itself about public key infrastructure, PKI, which makes TLS work. But this is about zero trust security, which deals with that. So then you come down here, and I'm always telling you guys it's an excellent book, but if you jump to page 41, they've got a primer on how this all works. So if you're like, Scott, I just never bothered to learn certificates. Well, go give yourself, sit down for 10 minutes, turn off Twitch, turn off YouTube, go read this, and it'll explain to you how it all works. And I think it's one of the best little primers on a topic that's not really what the book's about. The book's about zero trust authority or zero trust security, which is derived from this, though. So it's a really good book in general, but I would advise going and reading about it if you want to not have to just glaze over when people start talking about certificates, because you could be the certificate person one day. Maybe it falls in your lap and you want to use it. Main I use setup for Prometheus right now is black box export. Tells you how long you need to renew. Yeah, actually, I've seen projects like that. Mint. It'll count down, or it'll tell you how long. Yeah, that's actually a project I've seen with that. So then there's a reference in here for how you go write those if you want to. And then here's our basics of service level objectives, service level agreements, and service level indicators. You need to kind of understand this and know how this works if you're going to go take the test. We start with service level indicators. They are quantitative measure of some aspect of a level of service. So request latency or error rate. Again, error rate is a monotonic function. It's always going to be increasing. That makes sense, right? When I say monotonic, I mean it only goes up or down. And you only increase in errors. I mean, I have one error now. I could carry that one error for 3 weeks. But then once I have another error, now I have 2 errors total, right? Like your error rate always goes up. Error rate, if it's over time, does not always go up. So that's not a monotonic function. But if we're just talking about errors, anyways, you get what I'm saying, right? Errors are different than error rate, but your errors are always increasing. Your error rate may increase or decrease depending on how many errors you're having over a sliding window, right? And you can look for 5 minutes or 5 hours or whatever you want. You want to standardize those for frequency of every 10 seconds, data access latency, so time to last byte, aggregation intervals averaged over 1 minute, but those should always be the same, right? Yeah, error count goes up, true. But error rate over a 5-minute window is going to be doing different stuff, right? Error rate may stay at 0 and then only go up, at certain times of the day or whatever. So that's service level indicators. I need to reorder these because then service level objectives come from those. They look at service level indicators from less than an upper bound or greater than a lower bound. So they want to make sure that you're less than some upper bound. So typically if we're drawing a graph, right, a graph is going like this across our screen. The upper bound of the graph is where we don't want to touch. Some people think of that as a high water mark, although that's not exactly what it is. It's an upper bound. And a lower bound is the lower part of where it should go. And when we do like Six Sigma and statistical process methodologies, we try to get that upper and lower bound as tight as we can and keep the instances of whatever observable thing that we're doing that becomes a metric within that upper and lower bound. And that's all of what statistical process controls, SPS, right, or SPC, statistical process controls, are about, is being able to tighten that upper and lower bound so that we don't see errors within a system. Because again, obviously, you can just be as janky as you want, and then, but we try to control systems. That all becomes part of like total quality management and Six Sigma and other stuff, which I highly advise engineers to go learn about. Even though you're like, it sounds like a project management thing, and I'm like, but it's an engineering thing, right? Engineers make things better. That's part of what we do. So the more you understand those things, the more tools in your toolbox to explain these other things to people. So, by the way, I've talked about this before. If you go to our Discord, right? Discord's free, and you go to our... I have it under Prologue projects right now. No, beginner start. It's under beginner start here. Here are 5 certs you can go get for free, and 2 of them are about that Six Sigma stuff I was just talking about. So you can go there. The training is free for these 5 certs, and the actual test itself is free. So again, I tell you guys, if you have no experience in all the industry, but you need to put something on a resume, here's 5 things right here that are free. So they're in the Discord. All right. So there's that. And then digging deeper, there's a whole bunch of stuff around service level objectives that are out there. One is the Google Books. Google has, if you guys didn't know this, Google has published free books that you can go download right now. You just go to sre.google. Site Reliability Engineer.google. And they will walk you through, this is down in one of the books, service level objectives. And this gives you some terminology around all of this stuff. Indicators, collecting indicators, aggregation. I'll link this to you guys so you have it. But again, this stuff will be also when I finally do put this up in the Discord, when I make it just... I have a little bit more work to do with it, and then it'll be better. You guys saw some of my drawings that aren't quite finished yet. And then statistical, they give you a lot of stuff. Aggregation intervals, right? This one is one of those things that I mentioned earlier. Standardize your indicators. Always look for the same things. Well, so yeah, we'll be on the exam. That's a good point. People bring that up a lot. If you just want to pass the exam, a lot of it, this is extra reading. But I will tell you guys, understanding like this stuff, choosing your targets, don't pick based on current performance. Keep it simple. That's one of the best engineering things I've ever heard. In fact, make things as simple as possible, but no simpler is probably one of my favorite engineering little truths. That's an old Albert Einstein used to say that, right? Make things as simple as possible, but no simpler. It's a good engineering rule. I'm a big fan of this too. Perfection can wait. I can't tell you how many times, especially in like the systems, when I do dashboarding, because I build dashboards for Knox and Network Operations Center and all this other stuff, and I can tell you that if you let a lot of people input into what goes in a dashboard, it'll never get built. So you just start building it. And then people start to go, oh, that's kind of interesting. And oh, that's kind of interesting. And over time, people keep building. And this is also one of those agile methodology principles where it's like just working code over documentation. Like get something built, and then we can refine it from there later. I think I told you guys, one of my buddies, I'm not going to call him out by name. We'll just call him John because that's his first name. I won't tell you his whole name. His whole job at Lockheed Martin when I worked with him was this guy would design stuff, right? He would build stuff, and then, and I'm not exaggerating this in the least, he had a team of like 50 engineers that followed him around and productionalized the stuff that he did. And you say, really? That's like what their job was? Yes. This guy was sharp. And he would build something and make it work once, and then he would toss it over the wall, and those guys would go productionalize whatever he built. That's what he would do. That was his job. He was a research scientist for us. He didn't productionalize stuff himself. He just made sure it could get it to work once. He did some really cool stuff with satellites that was super impressive. But anyways, look at all this stuff. There's all kinds of good data and things to know in general about this stuff. Good old John, yeah. All these different things to study and read about. And I've posted these blogs in general are up in the Discord in different places. I think like some of the SRE pieces and stuff. But this is for people that want to go through and get ready for this cert, more things to read about. All right. So then the next part is like the fundamentals of like the system architecture, configuration, and scraping. We've touched on some of this as I was showing you like in the home lab. Understanding some of the limitations, we kind of hammered all the pieces of that. Data model and labels. Labels allow us to look at things with dimensionality. So we actually touched pretty much all of this except for the exposition format. So we'll go into that here. And then I probably have to drop because I do need to eat before I get back to this working session that I'm in. And we'll get back to building stuff here. So, all right. Anyways, this is system architecture. This comes from the Prometheus IO docs. You've got Prometheus server sitting out there. It's doing retrieval. It's doing pull metrics against the different jobs and exporters you have out there. There are all kinds of exporters, but everything is considered a target, right? So it's a target, whatever exporters are on one of the targets. So you can have multiple exporters on a target. So there was like a question earlier. All exporters are on a target, but each target has at least one exporter, right? So they can feed data up. But you can also have push gateway, and you're going to still pull metrics from the push gateway. So that's an important thing to note. But short-lived jobs can push over there. Remember, nothing that ever exists here is ever deleted. Or another way to say that is everything that's pushed here exists forever in the time series database. It's never purged out. It'll always be there, even like 7 years later, unless, well, that's another point. By default, the Prometheus server saves data for 15 days. And you can configure that as you call it if you want to. In fact, in my home lab, it's set to do 15 days. And that's right here. Cat. Oh, I changed it over to 31 days the other day. So now, actually, I meant to go look at this. So we can go look in my home lab and go to one of my Prometheus instances. So that's like my web server info. This is coming from Prometheus. And then I say, I want to know for the past 30 days how my servers are doing. And when I originally did this, it was only at 15. And then now this is, well, we did it on the 2nd of June, right? So now we're almost to the end of June and we still have time to go. We still have load on the server, so I can see where my server peaked. Well, actually, by the way, this load is not a very high load against my web server because, you know, whatever was happening. It's the load is against the number of CPUs you have, so that's not very high against that node. Let's see, which node is this? This is 200. So this is my 200 is my server that I care about. It's my hostbox server. And here's its disk utilization, not using much of the disk. Disk I/O, very little of the disk being used throughout the day, probably as things were happening. That looks pretty at a pretty normal interval for whatever it is. So something may be happening. Looks like there's some kind of read. Maybe some kind of scan is happening in my environment. I know I have a daily scan of my entire environment, but this looks like that's once a night. Yeah. Yep. So that's when the scan is happening according to my Clam antivirus. So my Clam antivirus scans in my home lab environment every night, right? And I did that just as like a project to mess around. But then this data, now we've got 31 days of data that we're going to be able to look at. All right. So get rid of that. That's where you set that, right? So it's an important thing. Get rid of that. PromQL, you can come in and you can go look and you can pull information out of Prometheus with API clients if you want. You can use the web UI like we were in that little test environment that I linked earlier, or you can use Grafana to pull the data. So there's all kinds of different ways to visualize data. This isn't going to be great for end users, and this isn't going to be great for end users, but Grafana is perfect. You can have read-only dashboards and read-only accounts that can go in and just stand it up on the NOC, up in your network operations center. I put them on big 65-inch screen TVs on the wall, and then I just, like, you guys might think I'm kidding about this, but I literally, when I build these, I just turn on this little tool right here. Has anybody ever seen this? Anybody know what that is right there? You're like, well, isn't that in Chrome? Yep, that's in Chrome. Thing called revolver tabs. And you can configure it to revolve your tabs. So this will just revolve, oh, nobody's in the dungeon. This will just revolve my tabs every 10 seconds. And then up there on my network operations center walls, when they log in as the user and then they click into their Chrome, you just set it up to open all those tabs and have revolver tabs on, and it'll just go through all of your, hey, there's Ranger. I didn't realize it was still light out. I guess we do have light here for another hour and a half. There's Ranger down there licking his bed, being a weirdo. I guess we're watching him where he sleeps, so I guess we're the weirdos, but we can watch, right? We can revolve just through all the stuff we want to monitor in our NOC and have what's called HUDs, heads-up displays. HUDs are just heads-up displays of system information across a whole cluster. And then we can, yeah, I mean, yeah, we can't, we're the pot calling the kettle black if we call Ranger a weirdo. But yeah, so here's the thing, right? And then we just rotate through them. And you might say, Scott, is that like a real? I've used that in real big solutions, guys, real big ones. Just something with Grafana just spinning around, and it's valuable. You got the HTTP server. That's where the UI queries are coming in, and then we can push alerts to Alert Manager. I don't know Alert Manager well yet, so I need to learn this better. And then you can notify things like PagerDuty, Ops Genie can be reported to, email, and I think that you can notify to an HTTP endpoint. So some of you that, if you use cloud providers in any way, you can build your own little HTTP endpoint, which is basically just like API gateway, and you can send alerts to it. And that alert can be configured to have one, it can be certificate based, so that's fine. But you can also have it have like a header. It only accepts a certain header to come in. And so now you've got HTTPS, you've got TLS level security, which transport layer security, right? Layer 4. And then you've got your header, so it's only going to accept things that are signed and then come in, and you've got a reasonable level of security at that point, right? For your alerts to go to whatever. And then discover targets. You've got different service discovery that can be out there. And these are all the pieces you need. And then this comes from their docs on how, let's turn that off. This comes from their docs on exactly how their architecture works. You might have to open this in a new window and then look at it like this. Boom, there's all your info, right? And then they talk about, different components of things that you need to know. And this is one of the reasons I would for sure go in and build your lab at least once inside of Killer Coda, because then you can touch a lot of these pieces, right? Just like I'm doing in my home lab here. When I keep pulling that up, I'm just going to a real server and looking at how it was turned on and what it's doing and its configuration, right? Well, that's prom QL. Here's its configuration right here, right? All right. Scrape configs, these are detailed. There's a set of targets and parameters describing how to scrape them, and they're defined inside of the YAML configuration file. We looked at those. They can be static or dynamically assigned, meaning static is it gives the exact one, and dynamically is where I say go read all of these files like we do in my lab. Then there's global defaults, but you can override them individually. So if we look at this here, right, this is what this looks like. Etsy Prometheus more Prometheus.yaml, right? And in here's all my scrape configs down here. Scrape configs, and the job name is Prometheus in this one, and it's a static config against my local machine. So boom. Then I'm on my own Prometheus node. I'm looking at 9100, which is node exporter. So I'm assuming node exporter is set up on my node. And those are the two default ones that came with it. But then I have a job named Prolog Lab Scrape, and that's the one that looks locally with the file SD configs, and it goes and looks in there and finds these dynamic targets, right? And if you want to go look at all of the different scrapes that are available, here's all the configs, all the scrape configs. And there's a whole bunch of them that you can use. But look up here on the right. Here's all the different types of scrape configs. You can do a TLS, so you can have a TLS part of the config. HTTP SD config, this is a very common one. And we can just go and find a host and then tag labels to them. The ones that I'm most used to are for sure going to be the file SD. And the file SD just goes and has those files that you can read, all the files that look like whatever.json, right? But then look at this. Maybe you got an EC2 one, and you can go and here's all the EC2 instance information that you can put. So you can have all kinds of config. They give you an example here. But let me just caution you. You got to put an AWS secret and access key here. So this may need to be a read-only account. And then that account that you've given that secret access to, you're going to have to do some identity and access management policies to make sure that it has read-only information to be able to go connect to EC2 information, right? And you may have to test some of this config stuff to make sure that you've given it enough information. right? And that it has the right values to go read that stuff. So there's some configuration stuff that you might have to do in there as well. All right, so anyways, that's a scrape config. That's something that you need to know about. And then understanding Prometheus limitations. Long-term support is on a 10-year cycle. That's pretty standard for most LTS releases. Every 6 weeks, they have a new minor release cycle that begins. And then the local storage, the limitation of local storage is it's not clustered or replicated. Like if you just have it sitting on a disk, well, that makes sense, right? But compaction happens in the background. Initially, you have 2-hour blocks, and they're eventually compacted into longer blocks in the background, which is either 10% of data retention or 31 days, whichever is smaller. So if you're retaining less than 310 days, it's going to be 10%. If you're doing greater than 300, wait, let me think about that. If you're doing 310 days, they're going to be the same. If you're doing less than that, it's going to be a smaller amount, but it's going to be 10%. So say you're doing 200 days, you're going to get about 20 days of retention will start to get compacted into blocks, right? If it's greater than 31 days, it starts to go bigger. But right at 310 days is how much retention you would need for that to flip over from one to the other, if that makes sense. And it says whichever is smaller. So it'll, yeah. Let me see. Hold on. Let me think about that. Yeah, it'll never go over 31 days. Yep. Because it's whichever is smaller. So if you go over 310 days, 31 days is what it'll be at. Yeah. That's a way to think about it. You can think of this as it races up to 31 days and it doesn't go higher. Juliet, on average. No, you set the retention once. So, I mean, you shouldn't, I mean, you could be changing retention, but you'll be affecting how the server works. You only set retention on this once. Where's that? You set retention as you start the server, and that really should never change. I don't even know what would happen if you set that down lower. I think you would immediately lose all the other data. Yeah. So you set the time retention one time. And by the way, normally you can set stuff like that down in the config file too. Like I always thought that's how you did it. But in this case, I haven't found a way to set that inside of the config file. I've only been able to set it out here. So if anybody wants to look that up and say, I found a way, I'd say, well, that's really cool. I don't know how to do it. I've always had to set it out here, even professionally. So I would love to be able to set that inside the config file, because then I can save the config file. But, you know, it's fine to have it in the service file. It's whatever. You save the service file too. But I'm just saying, then you have it all in one place. This is weird because it's like the reason it's weird is because if you said, hey Scott, can you help me and set this all up, and then I just give you my config file, and you're like, oh, that's awesome, I'll tweak this or whatever, but I didn't give you my service file, then you're like, why does mine behave different than yours? And I'm like, well, because there's things that are tagged in there that aren't tagged in the config, and that to me is super weird. I want everything in one place. Simplicity's sake, right? I've caught myself, people have asked me, hey, where's that defined? And I'm like, I don't remember. And then I've had to go look it up. So now I remember because I've been asked so much over the years, but that's where that's at. All right. Data models and labels. You got metrics names. They need to be like, they need to be a general feature of this thing that's being measured. So we name them a certain way. They enable Prometheus dimensional data model with labels. So when we put labels on things, labels are those things that then we can say by job name equals, or CPU, equals, or idle, or whatever. We have all these labels on the data that we can go and search by. So our labels need to be like this. We filter and aggregate based on dimensions. They must be either A to Z, lower or uppercase, with an underscore. And then they have to be 0 through... Did I mess that up? Is that supposed to be 0 through 9? I think I messed that up when I typed that. And then if you have 2 underscores at the front, that's reserved for internal use. So don't use those. Although they are real, you're not allowed to use them. Labels may contain any Unicode characters, and labels with an empty label value are considered equivalent to labels that do not exist. So that's important. If you have empty labels, they're not getting tagged to your data, which makes sense because you couldn't query by them anyways. So there you go. Common notation is you call a metric by its name, and then you call its labels inside of curly brackets. And you guys have been playing with that, right? And then there's some naming best practices. Here's an example. So API HTTP request total, methods are post, and handler is /messages, right? And then it would only find those things that meet those two dimensions based on the labels. And that's their dimensional data model. And without going into that too much, that's what you're practicing if you do that. If you do this right here. You come in here and you do your... Literally clicked off of it instead of clicked into it. Where's my Prometheus home stuff? Can I just get it here? Oh, boo. All right. 192, 160. I don't remember where it's at, guys. I gotta go find my... Oh, there it is. I was gonna say I have to go find my Prometheus. But yeah, here we go. And then, you know, whatever we want. And CPU, right? Node CPU seconds total, something like that. And then we can query, and then look, here's all the dimensions that we can query across. These are labels. Job is node, mode is idle, team is infra, and there's all these different modes. And then we could, again, aggregate them by dimensionality. That's their terminology. Then there's some best naming practices that are good. And those best naming practices look like this. This is, by the way, I didn't put this in here because there's a lot of stuff, but it should start with a single word. So like Prometheus, process, HTTP. That should be the single word start. Wait, do I have that later? I might have that later where we kind of talk about this. But then it has, you know, what is it doing? And then at the end is the unit of time. Seconds, bytes total, info, timestamps. That should be the suffix at the end. In between should be a description. So process CPU seconds, process total queries or total threads or whatever. And then those are going to be in between. But at the end is total and the name is at the beginning. Those two things always need to be there. Then they have the base units that you should always follow. And this is part of the test. You need to know what the base units are for the test. So don't let them trick you up by saying, you know, temperatures and something else. They say that you should be using this temperature or whatever. All right. Exposition format, simply put, it's text-based if you want to export metrics, but your preferred language doesn't have a client library. So if you don't have a library, you can actually just expose on any port you want, /metrics, and then point it as a target as one of these HTTP targets right here. So here's like a static config to a direct target, and the metrics path defaults to metrics. And if I were to make one of these against some node, and then in that node I was just to put this together and have my own data being written out there, whatever my query interval was that I gave, it would come along and it would scrape that that data that I want. So I can have my own I can write my own exposition. It's simply a key value pair. Look, whatever the metric name is, and then the value. In this case right here, when we're looking at this is a histogram. Yeah, they mention it right here, but this is the duration in seconds, and then it's turned into that should be, yeah, if it's less than or equal to 5, 1, 2, or 0.5, and then there it's counting up the numbers over there. So then when you graph it, you get a histogram. Histograms always look like, where's a histogram? That's a histogram right there. Histograms always show how data is distributed. It's very, like a lot of times in statistics, if we want to look at data before we know much of anything else about it, we'll plot out the mean, the median, and the mode, and then we'll look at the standard distribution of it. And things will turn into either, in this case, a standard distribution, or there'll be like a bimodal distribution, and then there's other types of distribution. What are they? Gaussian? I don't know. I don't remember all their names. I just know when I see them, right? Yeah, most of the language have libraries that you can do. Yeah, that you can send this stuff out with for sure. In fact, I have it in here somewhere, what they all look like. So here's digging deeper. Here's your exposition formats, right? Those are the things that you need. But here's the client model repository. So if you needed, no, that's not it. Hold on. There are a lot of clients out there already. Here's our client libraries. So if you said, hey, Scott, what clients are already there? I haven't seen OpenTelemetry used much yet, but I've heard a lot of people talking about it the last like couple years. Mint. So it would. I think it would be. I think it would be good. Look, here's the common ones. Here's unofficial ones that are still pretty popular, and then they have. When you look at all this, you go, okay, well that's a good amount. But then if you go and you look at the registered ones, so here's a guidelines on writing client libraries if you want to write your own, because some people want to. But mostly, that's probably most of the language people are writing. I mean, this probably, if I had to guess, like, that's probably 90% of, well, I want to be careful how I say that. Go and Rust and Python, well, and then Java too. That's for sure most of the web code going on, right? Those things. I guess if you include like C and C++, there's a lot of back end stuff. But this is stuff that's doing web, and this is the stuff that's moving around in like the DevOps and the SRE space for sure, right? For most of my buddies that are doing like SRE are mostly in Python, right? But anyways, look at all this, and then they have, I don't see it, but they have all the default. So these are the general ones, but then when you go in one of them, I think it'll drop you into. I don't see it, but they have all of the common. They have all the common ports, and there's like literally like 1,000 of them that are just common ports that these different ones have registered. So they're the registered ports that you can use. You can also just use whatever port you want and scrape whatever port you want. But there's ones that are set as well, so that there's a standard. But again, nobody's going to come and like knock on your door and take your Prometheus off your server, if you don't do them. It's just that they're there. Then there's some storage topics, which again is just back to the documentation. This is all my digging deeper, so like when you get to the end of whatever section, then it would just be more info. Where'd that go? Come on. Storage stuff says, yeah, on disk layout, where does it go? And then how compaction happens and how you do the operational aspect. And again, you have these flags that, again, they have to be done as you call Prometheus, which is super weird to me. Anyways, and then they talk a little bit about remote storage if you use remote storage for things, and then some other integrations that you have. All right, where are we at? Turtlebeard Media. Turtlebeard, I'm pretty much done actually. I gotta get off of here and do some more work. We were just doing. We started off with getting into Linux, and I was just kind of asking questions and showing stuff that I've asked junior engineers over the years in technical interviews. And then we were talking about, the people wanted to go over PromQL a little bit. What I'm going to be doing, though, and I probably won't start it this weekend. I was hoping to start it this weekend. But I'm going to do all the Ansible stuff. So we're going to start at the beginning with people that have never touched Ansible all the way through. And we're going to use, again, that Socratic method. We're going to do each of the labs. And then we're going to ask ourselves questions and make sure that we understand what we're building and what we're doing. And that's a very common model for how I show how things work or whatever. So, yeah, Bacchiotomy, it's good to meet you. Good to have you in here. And, yeah, hopefully this stuff's useful to you guys. I'll just stop this here. This will be up in the Discord sooner than later. But I've got a few things, again, in my notes to clean up before I go putting this anywhere. And then I'm going to go take this test probably at the end of next month, because I'm going to be really busy at the beginning of next month doing some project work. Well, it's starting now, but going forward and stuff. So, all right, so I'll drop off of here, and let's find somebody to raid on the Twitch side. Again, hopefully this stuff's mostly useful to you guys. On the YouTube side, I don't have any facility for raiding out, so hopefully you guys just hang back around next time you get a chance. Let's go find somebody that is doing... we'll go hit Harold up. Harold's always doing fun stuff in the tech space, so we'll go raid him. And I appreciate you guys coming by. I will talk to most of you Sunday when we do labs. We do all labs on Sundays, guys. That's what we do. All right. Take care.